Right. Just look. Click information here on the level. Right. Right. So 8.0, a lot of features in advance. If you're using 5.7, it's EOL. We really strongly encourage you to use 8.0. Right. There's new release 3 models coming up since July last year. Right. This is a big ask from many of the big customers saying that in 8.0 we've been doing a continuous release model where we include new features as well as stability and bug fixes together as one. And that bleeding edge features sometimes can cause pain because they can cause unpredictability and other side effects. So in 8.0, we have now moved to what we call a innovation release, where those new features that are being experimental can be tested in this. They're still production grade, but the support for it is short term, is every quarter, which means that if you're using 8.1, you want to get the bug fixes, go to 8.2, 8.3, or 8.4. And with that, the long-term support release would just include stability and bug fixes, which means the next release itself, upcoming in this quarter, in April, 8.4 will be released. 8.4 will become the next LTS. When 8.4 comes out, by right, what should happen is 9.0 innovation will start. So this will carry on for 2 years. Every 2 years, every quarter, they'll be released. 9.7 would be the next LTS. 10.0 would start, and so on and so forth. This, if it's accordance to, if the release schedule is in accordance to what they plan, this will be what come out. The exception here is in 8.0. 8.4 was the first LTS, which does not follow this rule, because we feel that because 8.0 will sunset in 2026, 8.4 coming out this April would sunset in 2032. We'll still enjoy the 8 years of support as well. So this is what happens. And typically when that happens, all right, these are the upgrade and downgrade path that are possible, where you can actually do in-place upgrade from the innovation release to the next innovation release of the same major version. All right, you can do in-place upgrades accordingly. From one LTS to the next LTS, these are the various types of supported. And from an LTS within the same version, these things are supported as well. So the upgrade path and downgrade path is all shown here, all right? Except that when it comes to downgrade, you can downgrade within the same major LTS release. The file versions are fixed so that you can actually move up or down between them. Anything else in between, you have to do either async replication or use a dump and load to export and import, all right? So this is actually what happens. So expect this coming up in 8.4 onwards, all right? I just want to cover a few features quickly, all right? MySQL shell, all right, allows you to check for upgrades by using the command, the MySQL shell checker facility, all right? Once you run this, you can check the target release from up 5.7 to an 8.0 release, or even beyond an 8.0 release. Let me see whether this is running. Sorry. Oh, sorry, this is a PDF file. All right, so my other file shows it. All right, why upgrade to 8.0? Better concurrency. The redo log architecture has been revamped. Used to be a single choke point on sync here. We've made it such that the log consumers are non-blocking, and therefore you could see from here that, what has happened is we have actually scaled up the performance of the redo logs and its consumers in this way. The other advantage is the redo logs now are dynamic. You can change the size of your redo log, restart it, all right? And my colleague Mayank later will share about the dynamic resizable redo logs in version 8.030 and beyond, all right? So this has improved concurrency for the transactional database side of things. So this is one of the key reasons why upgrade is encouraged on 8.0. The other thing, the undo format has changed. All right, this used to be a blocker in 5.7. All right, you can only change how many undo table spaces you need, and they're fixed size. But once you change it, when you create the database, you cannot change it anymore. You cannot increase it or decrease it. In 8.0, we revamped the whole architecture of the read undo logs, about 127 undo logs, each with 128 rollback segments. If your database is doing a lot of batch and a lot of reading of transactions, you can increase or decrease the size of undo logs dynamically. All right, it can be increased, and so this helps to improve database availability. All right, you size it according to what you need, and this is now possible in itself. Right, there's also advanced features like undo truncation. These are all automatically handled and has been improved in the later versions of 8.0. All right, resource groups is another improvement whereby you can set priority for all different type of workload and database. For example, you want your batch workload to run at a low priority, but you want to maximize priority for your online transaction database, right? With resource groups, you can set the affinity in such a way that you allow your transactional database to, the transactional workload to be higher performant, yet your batch still runs, but at a lower priority. So this is now possible with resource groups. This tunes, but it's only restricted to certain OSs. For example, it is well implemented in Linux, not so well implemented in the other OSs here. All right, so priority can be set, and this actually affects CPU affinity for those processes affected. All right, so this is actually another reason to go 8.0. All right, table space truncation has been improved. All right, we used to have a problem with adaptive hash indexes in the sense that this would actually slow down as the number of objects increase when you try to delete and truncate. With the new fix, all right, no matter how many tables you create or delete, right, the time to truncate has improved dramatically up to about 250 times, depending on depending on the number of tables you have. All right. The other thing we have improved is columns. In the next release, when you need to actually have a table, there's no primary key. Invisible column is the way to go because it would actually allow you to create the primary key based on the invisible columns, but the primary key, it would expose that column itself, all right? You do so that your application, even though it does not have a primary key, it will still be adapted and it allow it to be, for example, transformed into a high availability application, which requires every table to have a primary key. Invisible indexes, very useful for soft deletes or preparing a new application code deployment without impacting existing queries. Or if you have analytics and a batch job that you're running, you don't want those indexes impacting your existing workloads. What you can do is you can override with the optimizer switch for the session of the batch job or the reporting job to expose the invisible indexes, and they can run and actually take use of those indexes, right? The other thing is generate invisible primary key, GIPK. Very useful when you are having old legacy tables, no primary key. With invisible columns, this will be generating a primary key for that table alone. You can now actually add HA, like InnoDB cluster, and clusterize and add HA to those tables for those legacy applications, all right? Quickly, security, roles has been added. If you've used other databases, you know that roles is a very important part, not just for application ease of use, but also for compliance. Because when it comes to compliance, you notice that sometimes they say ease of managing your application permissions. It is easier to use roles to assign one time, define one time, and assign many times. And this helps you to actually simplify access management in that sense, all right? So 8.0 has now matured onwards with roles added in the database. The other thing that we added to improve security is the use of dynamic privileges, where now privileges can be tailored to a specific task without giving the use of super privilege, which tends to be too wide a permission and prone to abuse. This now helps you the task to be performed in a very fine-grained manner, enough to do its job, and that's it. No permissions breach in that sense. This lower the risk for in such ways, all right? And the other thing that's very important is actually when you have old connections, typically what happens is that once it's reached, you have a connection lockout, all right? With the new feature, contributed by Facebook, all right, now you can have a separate out-of-band connection that does not contribute to your max connections. With this, the DBA can go in. If the session is full, he can now manage the database by killing off processes that's not needed. And they can optionally secure this connection by using a separate encryption certificate apart from the other side, all right? In 8.2 release, we have now restricted the use of TLS such that only the ones that has perfect forward secrecy, SAH2, and encrypts data using AES based on this, these are only the ones allowed, all right? So if you run a database and you connect to it, you would sometimes see this error, all right, that says that this will be deprecated. When it comes to a de-support stage in the later release, like 8.4, even this is, or even later when this is de-supported, you will not be able to use ciphers that are not listed here for TLS 1.2 or 1.3, all right? This is to prevent unsafe use of ciphers that are not supported anymore. All right, this is actually what we're supporting. HA, very simple. We have now added geographic redundancy. May not be one, it can be more than one cluster. The other one can be a single node. We also add admin API locking for cluster operations so that it will then obey. If it's an exclusive lock, the other DBA commands have to wait. If it's a shared lock, no exclusive commands can be run. So this has improved cluster consistency and cluster operations predictability, all right? And also improving security, inter-cluster and intra-cluster channels can now be encrypted, and the cluster admin user can now be protected by a passwordless file using passwordless authentication. Okay, so this is improvement in 8033 itself. All right, this is improvement. My colleague will talk about this later. Read scale out and transparent transparent database routing. All right, and clone plugin has been available for copying databases. All right, so this has been added in 8017. You can use this to provision a database by cloning, in this sense, or for copying a database that you need to do downstream for some development dev test purposes. All right, cloning is very fast on this because all these are parallelized and is auto-resumable. So this has been the benchmark that we've done against a few other tools. All right, MySQL shell and dump load is actually the preferred tool compared to MySQL dump. All right, so they should use this today. And the innovation release introduced, instead of dumping to a file, you can now copy from one database to another target database on-prem or in the cloud using MySQL shell copy without having a storage layer in between, which means that you can use the source instance, it is memory. You can now copy your database from one instance to the other in the other cloud, either on-prem or to a cloud database for that matter, all right? In a cloud database, certain restrictions apply so that compatibility is maintained for the cloud database service that you're targeting across. All right, so this works both for on-prem and on cloud. All right, developer productivity, you have VS Code and also MySQL REST services. These are now in preview mode. You can download them. And coming to the end of the talk, please stay for the other sessions that we have for MySQL by my other colleagues as well. So thank you for your time.
Thank you for a remarkably precise 15 minutes. It's really good. Is Mayank in the room? Hang around, David. Maybe there's some questions. You are? Okay. Any questions for David before he flees the scene? We have a minute or two while Mayank sets up. This is great. I've run into the out-of-band problem, TLS compliance issues, and the lack of role-based access control. So these are all, to my mind, very exciting features. Any questions for David? No? All right. Thank you very much. Sorry. Yes, that's helpful. One, two. Okay. Mayank is a consulting member of the technical staff for Oracle India and is going to talk to us about the InnoDB engine, dynamic read logs, and instant DDL. That sounds impressive.
Okay. Good morning, everyone. Can everyone hear me? The last row? Okay. So about me, my name is Mayank. I come from Bangalore, India, and I work in InnoDB storage engine development team in MySQL Oracle. And I've been part of MySQL since 2011. And today I'll be talking about a couple of features in InnoDB storage engine. So this is a safe harbor statement which says whatever I'm presenting over here is for informational purpose. And this is the agenda of today's talk. I'll talk about the configurable redo logs, which we have recently implemented in 8.0.30 and instant add and drop column in MySQL. I'll go in the details about these features and how they are implemented. And then I'll take questions if you guys have. So configurable redo log. So redo logs are write-ahead logs for InnoDB. So write-ahead logging is a mechanism in which we before we write the table space pages on the disk, we write this information of the changes into a log, and then we flush that information on the disk. Why do we do that? Because when we modify, when we are saying the transaction is committed, right, the changes has to be persisted on the disk. And if for each and every modification we start persisting table space pages on the disk, then IO might be bottlenecked. So what we do, this write ahead logging mechanism does is, it instead of writing the entire page on the disk at the time of transaction commit, we just write this information into a log and then we persist that log into the disk. So it saves IOs and the TPS goes high. And yeah, so but this write ahead logging is implemented as a redo log in InnoDB, and this is a circular buffer on the disk. So it keeps on rotating and keeps on truncating at the end when the redos are not needed anymore. If we have a large, very big redo logs, right? So it will save us a lot of flushes of pages from the buffer pool to the disk when the transaction is committed. But at the same time, if there is a server crash happens, the recovery will be longer because you have bigger redo logs, you have to apply them. To apply those bigger redo logs, it will take some time. But if you have a shorter redo log, the recovery will be faster, but you have to flush a lot of pages to the disk when the transaction is happening. So TPS goes down. So what should be the optimum size of the redo log? That's based on your workload and trial and error. So you can decide what redo log size you want to have, and then you can set this configurable variable InnoDB log file size. But the problem is this InnoDB log file size variable is not dynamic. So every time you set this variable, you have to restart the server. Then only it will take into effect. So there was a request to make it dynamic. So instead of having a requirement of restarting server, can we make it dynamic? So that's what we did in 8.0.30. So redo logs are still a circular buffer on the disk, but instead of one file, now we have multiple files using which we create this redo log. And instead of talking about the file size, I mean, we say this much MB of the file size, we don't talk about file size. No, we talk about InnoDB redo log capacity. So we say this is the capacity of redo log I want to have in my system. And based on that, we automatically calculate the size of each file and number of files to be created on the disk. So now if you look into the data directory folder, we have a dedicated folder hash InnoDB underscore redo in which we keep all the redo log files. So there are 32 files of redo logs right now. And there are few files who are suffixed with underscore TMP, and there are few files who are not suffixed with underscore TMP. So the file who are suffixed with underscore TMP are the files which are free to use. I mean, they are empty files. But the files which are not suffixed with underscore TMP, they are having redo logs which are needed by the system to have the consistency. And whenever we need more redo logs, whenever system needs more redo logs, one of these TMP files will be used to store the new redo logs which are being generated on the system. So if I put all these redo log files in a single line, so this is how the redo log, entire redo log looks like. So this is the checkpoint LSN. So anything before the checkpoint LSN is what is not needed in redo log for the consistency, because this information has already been persisted on the disk. Anything after checkpoint LSN is what is needed for the consistency point of view, because this information has not gone to the disk on the table space pages. And those white boxes are the files which are underscore TMP, which are not used. So now if we need more space, more capacity, or more space to store redo logs, these files can be reused, right? Okay, so these are the empty files. These are the files which are needed, and these are the files which are having redo logs, but they are not needed. So what we do is we delete all those files and then add the empty files to the end of the row. So now we have the redo log capacity increased, where we can store new redo logs. And if so, and if there is a scenario in which the redo log is getting filled up, all the files are being used, but checkpoint lesson is not moving further, then the DBA will get a message on the error log saying that your capacity is going down. This is the time to increase the capacity. Otherwise, the system will start throttling the transactions. We have observability. So in performance schema, InnoDB redo logs files table, we can see what all of the redo logs files are there, which are using redo logs. And for every file, what is the start LSN and end LSN. LSN is a log sequence number in redo log. And so the 5 files are there where the redo logs are generated. The rest of the 27 files are with the suffix _tmp. As I said before, these are the files which are ready to be used again. As I said, we can do this resizing dynamically. So let's say I want to make the redo log capacity 200 MB. So this is a command. I say just set global InnoDB redo log capacity as 200 MB, and then the resizing will happen. If you want to upsize redo logs, that means you want to increase the capacity of redo log. That is instantaneous, because we don't have to do anything. So whenever we create a new file, the size of the file should be according to the new capacity of redo log. But when we want to resize it down, so let's say from 200 MB, I want to make it 100 MB, then we might already have existing files which have redo logs, which cannot be truncated till now. So this operation happens in the background. Then how does user know this operation is finished or not? So for that, we have this status variable, InnoDB redo log resize status. If the status say resizing down, the status say resizing down, that means resizing is still happening behind the scene. But if the status value is okay, that means resizing has been done. And then we have this another status variable, InnoDB redo log capacity resized, which says what is the capacity of current redo log in the system. So if this capacity is less, you can dynamically increase it, or if it is more, you can dynamically decrease it. Now I'll talk about this instant add and drop columns, which we have introduced in MySQL 8.0. So before we go into this feature in detail, it is very important to understand the row format of InnoDB pages on disk. So how do they look like? So this is how a typical InnoDB page on disk look like. Every page in InnoDB have 2 dummy records, infimum and supremum, and the other records are connected in a singly linked list. Infimum is the head of the singly linked list, and supremum is always the tail, and the records are in between. And every record has 2 parts. One is record metadata, and another is record data. So record data is the one which user has inserted, and the record metadata is the one using which we can interpret the inserted record by the user. As I said, the 2 parts, the record metadata might contain the null bitmap for the nullable columns, it might contain the length of the variable length fields, and other some information. So now if I want to look into record metadata, how does it look like? It has 2 parts. One is variable size row header, and another is fixed size row header. The fixed size row header can be of 2 types. One is a 6-byte fixed size row header, one is 5 bytes. So if the row format is redundant, the row header, fixed size row header is always 6 byte. If the row format is compact, dynamic, or compressed, the fixed size row header is always the 5 byte. So these are the 4 format InnoDB supports. If we look into the variable size row header, it also has 2 parts. One is null bitmap, one is var length, fields length. So what are these? So var length, field lengths are the information about those columns who are variable length. Right? So let's say I say varchar 60, right? A column is a varchar 60, but when the user inserted that value, he inserted 10 characters. So the actual size of that column on the disk is 10 characters. So we store this information here. And then we have this null bitmap. So let's say in my table, I might have number of nullable columns which can have value nulls, right? So all those columns whose value is null in this particular row, we just keep a bitmap and set that bit 1. We don't space or reserve any space for that particular column in the actual data. We just say this particular bit is 1, so that column is nullable, or that column is null in this particular row. Yeah, this null map is not in the redundant row format. So in redundant row format, we actually keep the space for this column. So as we can see, right, so with the disk format and the record format, every record has information about the columns in which are present in the table. So if we want to add a column, or if we want to drop a column, this is very obvious that every records on the row or on the table has to be modified. And this might take a lot of time. So if your table is huge, you keep on going and modifying each and every record, it might take a lot of time. It is costly, it takes time, disk resources, etc. The table is also locked when this rebuilding is happening. And it is a problem with the replication also. So you do some this DDL add column on the master, let's say take X amount of time. The same thing goes and happens on the slave, again X amount of time. So there was a requirement from the customers and the user that can we make this thing instant? So this is the idea behind making this thing instant. So we say, is it possible to have this information updated, only the metadata updated when we do instant add and drop, instead of modifying each and every row? If this could be done, then there is no table rebuild, right? This replication will be benefited because we are not running everything twice on the long operation twice, once on replica and once on master. And the table lock is also not required. Table rebuild is also not required. So how did we implement this solution? So in MySQL 8012, we came up with a solution in which we can add a column to a table, but there was some limitation. Only the column add was supported. The drop column was not supported in this version. The another limitation was the column can be added only at the end of the table. So the column could be the last column of the table. It cannot be added at the first or in between any of the column. What we came up with a new design in which we can add column at any place, be it first column, middle of some of the columns, or at the last column. We can drop column from any place. So this design takes care of add and drop both. And the syntax is same, right? You just, after and first is supported, it was not supported before, and the drop is supported. How did we do that? So we introduced something called row versioning. So now, whenever we add and drop a new column or drop an old column from the table, we bump up the version. We say, okay, now the version of the column, a version of the table is X or Y or Z, whatever. And this version is stamped on the row itself on disk, saying that this particular row belongs to this version, right? And with this information, we are able to interpret any record which is stored on the disk. How it is done? I'll explain in the future slides. So, but where do we store this version? I said the version is stamped on each and every row. So where do we store it? So as I said, in the redundant row format, we have 6-byte header, and these are the different fields of that 6-byte header. And the last field was info bits. So in info bit, this particular bit was available. It was not used. So what we did is we used this bit to indicate that this particular row, if the bit value is 1, this fixed size row offset, a fixed size row header has a prefix of 1-byte version. Similarly, with the 5-byte row header, we have these different fields in the row header, and the info bit, this bit was available, which we used. If this bit is 1, it indicates that there is a version prefixed with this 5 bytes row header. Now with this information, if you look at any row on the disk, the fixed size row header, if that bit is 0, what is just before that is the variable size row header, which I told you in the earlier slides, right? But if the value is 1, so there is a version byte in between these two. So this is the information which is stored on disk right now. So as I said, now we are storing the record version for each and every record on the disk. The two new metadata we have uploaded or updated for the column is version added, in which version this column has been added, if it is an instantly added column. If the column is dropped, in which version it is dropped. With these three information, it is easy to interpret any row on the disk. How? So let's say I want to fetch a row. So all the columns which have version dropped greater than 0, that means this column has been dropped, right? So we don't need to read that column. So we can ignore that column value if it is there on the disk. all the columns whose version added is greater than the current record version. So that column value is not updated on the row. So we have to read the default value of this column from the disk. Okay, I'll explain all these things with an example. So let's say I did a create table. It has 4 columns, C1, C2, C3, and C4. I inserted this row on the disk. So VC1, VC2, VC3, VC4 is the value of those columns. Now what I did, I dropped the column C3. So then C3 is dropped now, and I added a column C5 with a default value C5 default. So you see the version has increased by 1 because I dropped the column C3. Version has increased by 2 because I added the column C5. So if I look at the metadata, this is how it looks like. So for C1, C2, C3, C4, the version added at 0 because they were already existing when the table was created. For C3, dropped version has become 1 because this is the version where the C3 was dropped. And for C5, version added is 2. This is the version the C5 is added, and this is the default value of the column C5. Now, if I want to read this particular row from the disk, if I do select star, what should be presented to the user? So with this information, we can see the record version is 0. Nothing is stamped on the row. I said the bit is 0. It's not 1. So the record is in version 0. Current version of the system of the table is 2, the latest one. C3 was present on disk because this is version 0, and C5 isn't present on the disk because this row is inserted in version 0. With this information, what do we do? When we read the row, we read the value of C1 because that is present. Now we read the value of C2, but we don't read the value of C3. We ignore the value which is stored on disk for C3 because C3 is dropped now. We read the value of C4, but we also want to read the value of C5 because C5 is not present on the disk. So what do? We read the default value of C5, and when the row is presented to the user, this is how the row looks like. It has value of column C1, C2, C4, and C5. So this is how the row is transformed, which is in version 0 to version 2. Now I'll explain this entire flow with an example. So let's say we have a table. It has 2 rows, R1 and R2. None of them have any version because we have not done any instant add and instant drop. I did a DML. I updated row R2 to R2 dash. Still there is no version, right? Because there is no instant add and drop done. I did a DML insert. R3 is created with no row version. Now I try to do it instant add and drop column. So when we do that, we don't touch anything on the row, but we just added some information or some metadata information into the dictionary tables. No row on the disk is modified, right? Now, if I do an insert, the R4 is added, but the R4 is added with version 1 because now we have already done instant add. And now if I modify this row R3, it become R3 dash in version 1. So now we have 2 rows, R1 and R2 dash with no version, R4 and R3 dash with the version 1. And when this information is fetched, we read the data from the table, we read the metadata from the data dictionary, and we transform row R1 and R2 dash into the version 1. Oh man. Okay, and then this transformation happens, and R1 and R2 dash are presented to the user in the latest version, which is version 1. And R4 and R3 dash anyway doesn't have to do anything because they're already in version 1. Yep, so this is how they looks like. Now the instant algorithm is the default algorithm. So if you try to add a column or you try to drop a column without giving algorithm is equal to anything, by default, we try to do everything instantly. If at all instant is not possible, we fall back to algorithm is equal to in place or copy algorithm. When we do optimize table or we do any other alter table which is causing the table rebuild, then anyway we are going to modify each and every row because the table is getting rebuilt. Then instant information is reset. And this row version which I said, right, each and every row is now being stamped with a version. So this row version has a limit which is 64 for now. We realize this add and drop column is not a very frequent operation in the real world. So the 64 should be sufficient to have a limit on the row version of 64. And if after 64 you try to add a drop a column with algorithm is equal to instant, you get this error that maximum row version has been reached. Please try algorithm is equal to copy or in place. If algorithm is equal to instant is not specified, I said you can, it by default, it try to do everything by instant. But if the 64 reaches, behind the scene, it will fall back to algorithm is equal to copy, and the instant information or instant metadata is reset again. Now the compatibility, right? So upgrade. So is there any issue with the upgrade? No. So when we upgrade with any previous version to the latest version, there is no transformation of row is needed on the disk. So that upgrade is as it is being done now. We might have rows which are inserted before the first implementation of instant add. We might have rows which are inserted after the first implementation of instant add. Or we might have the row before the new instant add implementation, or rows after the new instant add implementation. All these rows are handled correctly behind the scene. And as I said, once a table is rebuilt, you do optimize table or alter table, which causes table rebuild. All this instant metadata is reset. And export and import. So when we export a table space, which has or the table having instant add and drop column, this instant information is written into CFG file. So now if you want to import this CFG file is a must. So you have to have a CFG file if you are having a table with the instant add and drop columns. And this is a table which says what is all supported. So no instant add drop in the source table, no instant add drop in the target table. Anyway, it is allowed. Source has instant add and drop. Target doesn't have instant add and drop, but target has all the columns which are present in the source table. Presently, the import is allowed. Source doesn't have instant add column, but target has not allowed because we don't know who has added, what column has been added, what column has been dropped. The source has instant add column. Target also has instant add column. The import is allowed only when the instant metadata is matching exactly. And observability. So we have these two tables, information schema InnoDB tables and information schema InnoDB columns to give some observability. How? So let's say I do a create table T1 with C1 INT, and we have n calls 4. 4 is because we internally generate 3 more columns. One is row ID, one is transaction ID, and one is role pointer. And the fourth one is the C1. The total row version is 0 because till now no instant add and drop has been done. This instant call is the column field which was used to give information about the previous instantly added columns, previous implementation of instantly added columns. So we have kept it for the backward compatibility. And now if I want to look at the metadata of the column C1, I see the has default is equal to 1. If had it been the case, this C1 was added instantly, this has default would have been 1, and then it would have the default value. But right now C1 is not added instantly, so we are getting 0 here and the null here. Now let's try to Now let's try to add a column C2. So C2 is added with the algorithm is equal to instant. Now n call has become 5 because the new column has been added. Row version has bumped to 1. And now if I look in the metadata of C2, it says the has default is 1. And this is the default value of this column C2. Right. Now this is what I tried on my system, my development machine. So I have a table with 8.3 million rows, and I tried to do add column with algorithm is equal to copy. It took 29 seconds. Then I tried to do algorithm is equal to instant. It was done instantly. There are a couple of limitations. So we do not support this instant add and drop with compressed tables, which we realized they're not used too much. We do not support instant add and drop for the tables which have full text index. We do not support instant add for the DD table spaces. The tables which are in DD table space, those are the dictionary tables. Anyway, user is not supposed to modify those tables. And there is no support for the temporary tables. So temporary tables are not supposed to be very big. So yeah, those are not supported. And I have put the link of the 2 blogs where I talk about these features in detail. And that's it. Thank you.
Is Rafa? Is our next speaker in the room? Oh, no, time for Q&A without the next speaker doing setup. Do we have any questions for Mayank? Please, hang on. We have a stream, so microphone, please.
So if I not catch from your presentation, but according to a column add drop feature, it looks like your table will tend to bloat because you store old values of deleted columns. So I guess you need some cleaner, maybe, process which will compactify your data. So do you implement such thing?
No, so the bloating is, so we just keep the metadata information of the table, which the column which is being dropped, the metadata only, that this column was in this version, dropped in this. The reason we keep it, so we might already have some rows which have the value of that column. But when we fetch that row, we should not read that value of the column.
Yeah, it's the cleanup afterwards. So if you've done a bunch of instant adds or instant deletes more usefully,
yeah,
at the time you do the delete, data remains
on the disk. Yes.
Till you do an optimized table. Is that correct?
Yes. That the rows are remain at disk as it is. So if you want to do a cleanup, you have to do this optimized table, which will clean up everything.
So that was my question. Again, that was my question too, because there's a compliance issue particularly for data processors who have to be able to issue deletion certificates to customers. There has to be a way to positive remove data.
Yeah, so for that we have this optimized table, right? This command is there which will clean up everything.
So my second question on that was, you mentioned there's a limit of 64 row versions.
Yes.
Does that limit get by optimized table? Or
yes, it does. It gets reset to 0.
Wow.
So after that, you can just keep on adding instead and drop.
So it's not that you're going to add hopefully hundreds of columns, but you're not going to just kind of get into a dead end that you can't escape. There's always a way out.
Yes.
Pick a maintenance window, and that's beautiful. Is our next speaker in the room? Please set up now, sir. Right. We have still 2 minutes. Any other questions for Mayank? No?
We don't have any remaining questions. Thank you so much. Okay, so next up we have Rafa Alvarez, is that correct? A founder of Hananto, who's going to talk to us about why not become a chain, which I think is reasonable advice for everyone.
Thank you. Good morning, everyone. My name is Rafa, and this session is going to be about how to offer different strategies for high availability in the MySQL ecosystem. So we're going to see a few business names. We are going to talk a little bit about InnoDB cluster, a combination of proxy SQL plus orchestrator, HE proxy, proxy SQL, Wicaksono, MySQL, a homemade tool, and then a few questions. So a little bit about me. First of all, I'm a father of 2, and they deserve my time much more than computers. I've been in data for many years, MySQL DB for around 7 years, and
well, for the last year, my own adventure is going on, which is this, it's Gonarch. It's a MySQL professional service consulting company, and we are on that. So let's go straight to the point. And the first strategy, it's InnoDB cluster. And I think that it makes sense that's going to be the primary option because that's a native solution from MySQL to address this type of strategies. And sorry. And this solution has automatic failover. It works for virtually synchronous application. And before version 8.2, the way to achieve or to get this HA in place was to, from the MySQL router, I will go into details now about the architecture a little bit, to provide two different flows of connection or connection string, one from reads and one for writes. From version 8.2 onwards for MySQL router, that has changed, and now just with one single connection string, you can achieve the same. I'm not going to go into super detailed things, first of all, because we have a talk about this right after mine, and they will go much more in detail than me. But just as a glance, the ways this works is, yes, you set up your cluster. You have your primary, you have 2 replicas, or you can have 5, or the nodes you decide to have. And then you put the MySQL router on top of it. Usually, the most convenient way to do this it's to use the MySQL router to implement it either in the application layer itself, and then using as a sidecar or just an additional or an attachment of the application, and then it manages the connection to your cluster. It's worth it to mention that InnoDB cluster offers the option of a cluster set, which is essentially ideal for DR, for disaster recovery. And what it does is essentially you build your cluster, InnoDB cluster in DCA, data center A, then you build same in data center B, and you interconnect both in an asynchronous way. And this is important to mention that it's synchronous replication for obvious reasons. Otherwise, latency between the 2 clusters could be too much. Good heat performance indeed. And then you achieve a disaster recovery plan properly. Next one, personally, this is one of my favorites, to be honest, is a combination of tools. It's a proxy SQL plus orchestrator. Console comes into picture as well. Sorry. The goal is the same. I mean, what we want to achieve is same. It's auto failover, fault tolerance, which it's going to become the HA solution. This one has an addition of the auto topology discovery that's offered by orchestrator, which essentially means that as soon as a node implements or joins the cluster you have, it will be recognized by orchestrator and then from proxy SQL 2. It's important to highlight that this strategy is more suitable for asynchronous replication. This is a classical replication where you have a primary and a few replicas, as read replicas, and then they are serving read traffic. In here, what we do is the client application will connect to the proxy SQL as a proxy layer, same as for MySQL router before. You can use one single connection string as well. You can use split connection strings. You have multiple ways to connect to proxy SQL. It depends on how you do the setup. That's up to you or to your requirements. And then from there, it will connect to your cluster. What's the thing here is that per se, proxy SQL won't offer you the option to do an auto discovery topology. It won't auto promote primaries for you. So if a primary crash, the replica won't get promoted right away. That's why we implement orchestrator right here. And that's going to be like the one that decides what's the status or what's the topology of your cluster. This means that is this tool the one that will control if your primary is healthy, if your replicas are healthy, and if, for instance, primary is not healthy anymore, is not serving traffic properly, orchestrator is the one that will manage the promotion of a new primary and the demotion of this primary as a replica or discarded or whatever it happened. The thing here is that orchestrator out of the box doesn't talk to proxy SQL. So we put console in the middle. Console is going to be our, let's say, version of truth. Orchestrator will talk to console because he knows how to talk to console. That's implemented. So it will say, hey, this is your primary. Hey, this is your replica. It will save everything in console, and it will remains there. And the good thing here is that console, through console template, can talk to proxy SQL. So then we have the cycle completely closed. Now we have an orchestrator, which is the one that is managing the topology, saying to console, this is the status of your topology right now. And then console will be able to say to proxy SQL, hey, this is the information that I have for proxy SQL, so please react. So ensure that you know that the primary or the write workflow is pointing to the primary, the read workflow is pointing to the replicas plus primary depends on the implementation that you do. But this is key. It's important to highlight too that multi-data center replication is supported too. It requires a little bit more complex configuration. In essence, it's more or less the same, with the addition, of course, as you can imagine, of an additional cluster with an additional orchestrator here. And what we do for multi-data center replication is we add a cluster or orchestrator. So we add 3 nodes, and then we synchronize everything. It's a bit more complex, but it's doable too, and it works very well. Just a word of warning is that so far, orchestrator is not being maintained. From the original creator, last commit of code in GitHub was from January 2021. It's forked by Percona. There was some rumors that they would maybe maintain it. I have no idea. But the reality is that from the same date, there is no any pull request, any change in the code. So far, looks like it's a little bit unknown. Would be a pity. It's a really good tool. How are we doing with the time? I'm not following that. No, we're fine. So the next solution, our strategy, would be a proxy layer in Galera. I put HE proxy because I talked about proxy SQL before, so you know, just to be a little bit fair. But the offering here is more or less the same. I would compare this kind of with InnoDB cluster in the sense of the deployment. It works more or less same. We put a proxy layer on top of the client applications. This one will distribute the traffic to the different nodes. So the important thing here is that Galera works in a virtually synchronous application. So you can have a multi-primary cluster. And thanks to the proxy layer, you will decide how you want your traffic to flow. You can have multi-master. It's indeed recommended for Galera. But from the proxy layer, you can decide to write only for one of the primary, or for the primary, sorry. That would be okay. And having this, you ensure that if one primary goes down, you have other 2 primaries up and running. It's just a matter to update the proxy layer, and then it will right there. Even you can have, for example, in HA proxy, you can have all the masters registered, and then it will automatically just select the available primary. It's a simple way to implement HA. Galera is, I really like it, but I have to admit that could be a little bit tricky sometimes. Yeah, sometimes it requires a little bit of a change of mindset from the application layer, but it's not a big thing. So far, this doesn't work very well for multi-data center setup. It can be done as well, of course. I mean, after all, almost everything can be done, but this will require much more configuration and probably some kind of custom coding to make the switch properly. But it's there. Next one is max scale. I'm not going to touch this one quite a lot because I didn't work with it quite a lot. But in essence, what it offers is just the same as before with orchestrator and proxy SQL. So essentially a topology manager and auto failover and a proxy layer all in one product, which is great. Again, you can connect just with one single connection string, and max scale will discriminate the traffic between reads and writes, or you can have different ports, different connection string for writes and reads. It's up to you and your configuration too, and it will go to the cluster. This can be either a asynchronous replication, so you can have a primary, a couple of replicas. You can have it works with Galera as well. I didn't mention it, but this is the very beginning that this is the native solution from MariaDB to address HA in their cluster, but can be used with MySQL too. It's not widely used, but you can use it too, which is the reality. The thing here is that MassScales offer two different versions. One is open source and the other one is enterprise. The open source feature is a little bit unknown for this application too. It's been maintained. I'm not saying it's discontinuous, it's not like orchestrator, but it's not clear. It's not clear what's going to happen in the coming months, if they will continue offering that open source solution or not. I don't know it neither. So the last solution that I want to talk about is Goran HA, something that is being built in-house. Sorry. Essentially, it covers as well, same as the other products, just to offer a full HA solution, same, which is fault tolerance, auto topology discovery, auto promotion of failing nodes, and that kind of things. Same as we were talking just for the others. It was only for asynchronous applications so far. The way that the traffic is split is through connection strings, so we are not offering one single connection string to distribute the traffic. And it's super important to mention that it's under active development. It's not production ready yet. Although I'm looking forward for testing people. So if you want to talk to me later, it's open source, of course. You have the GitHub project here. Just feel free to have a look in there. Okay, so this is the end of the talk. If anyone has any question, I think that I want to be too fast, maybe. But I'm Spanish. That's quite common with me.
Thank you. It is not often that I'm dealing with speakers who have finished early. Okay, questions, anyone? Hang on.
First of all, I want to thank you for your inspiring speech. And I have questions about the proxy SQL diagram. As all the solutions that you provide, I noticed that proxy SQL has two elements, that console and orchestrator. I don't know about the functions of two elements. And can you explain more clearly about its role in the system? And can I just use one, not two, both? Okay. So I just know about more the function.
Okay, thank you. So if I understand it correctly, you want to know more about this?
Yes, about the console and orchestrator.
Okay. So is there any specific you want to know about console and orchestrator, or you just want me to just give you a little bit on how it works?
Just give me a general view about it.
Yeah, sure. So essentially, orchestrator, by default, has an option in the configuration to write what's the primary, so the primary information, directly into console. Okay? The information about the replicas requires from you to build a script to do it. Okay? In essence, what you end up is having an orchestrator node that is capable to write what's the information of the primary, so who is the primary, and what's the port, and who are the replicas, how many replicas you have, and which port are they accepting connection, usually 3306, right? Then that information goes into console. Usually, a good approach is to have console locally installed in your orchestrator, so latency will be very good. So yeah,
Okay, thank you.
yeah,
Yeah, I know more.
thank you.
Okay. We have a stream. Please use the mic.
Okay, thank you so much. Yeah, okay. Do you provide automatic failovers for ClickHouse? Because you are using asynchronous replication, and how to provide complete consistency in this architecture?
Yeah, yeah.
Thank you.
So, so far, yes, we provide auto failover. The way we provide it, whether it can be customized a little bit, but the logic is that if a primary just stop accepting connections or it gets essentially timeout from the checker, it will decide which is the replica that should be promoted. The decision will be based on factors that can be set up by the client, but by default, it's going to check who is the replica that has zero replication lag and the same binary log coordinates or GTID coordinates to ensure that that sometimes seconds behind master is zero, but there is a replication issue. So we double check that both parameters are okay, that are in sync with the primary, and then it will use that one as a replica. It's worth it to mention that can be adjusted. So the users can decide, no, I don't want to have that. Because what happens if both replicas are slightly out of sync? I don't have a primary anymore. So you can decide to use a different approach, which is an instant failover. So it will just take one. You can set up priorities if you want to. If you don't, it will just go for the closest one and promote it. If it's losing data, I don't care. It's available. So you can decide what you want to have. Is that an answer? Yeah. Thank you.
The automatic failures will be driven by the ClickHouse HA or the MySQL. The automatic failovers will be driven by the HA.
Correct. Yes.
Okay. Thank you.
We do still have lots of time, but it's okay to have a break too. Were there any other questions for our current speaker? No? Oh, hang on, we have one. Okay.
Hi. Amongst all the solutions you've just presented, I'm still not sure which solution is the best to pick. Can you do a bit of comparisons between all of them?
Yeah, it makes sense because there is no best. That's the real answer. Depends on the business case. Depends on what you want. I'd say I have a well-designed application. Yes, I have a well-designed application. Well-designed is, in this case, is, for example, that the size of the transactions are small, they are properly contained, they are not huge inserts with thousands of inserts in it. So I can afford having synchronous replication. I can go with this solution. This one is simple to implement, simple to maintain. Okay, there's a guy here, but I really like this solution. It's very efficient. Okay, if you're in the MariaDB ecosystem, you can go with Galera. Requires a little bit more of setup, but just a little bit. It works. It's very solid too. Now you say I have an asynchronous cluster because sometimes I have, I don't know, network latency, or I really don't care about, having all the data in sync all the time with my replicas. I can afford that. It's okay. This solution is super solid. Problem is this one. This is a blocker right now. So if you have an asynchronous environment, I would still go with this because orchestrators not be maintained. That's true, but it works. So yeah. About max scales, for MySQL, I don't see it quite often. And about the Golang solution, I cannot offer it because it's not production ready. It will be, for instance, but not yet. So depends on what you need. I don't know if that really answers. There's no one single one, but depends on what you need. You will go for one or another. And that's going to be usually not only, but mainly based on what type of replication you have based on your needs, on your business needs.
Okay. Anybody else? No? Well, in that case, thank you so much.
Thank you, everyone.
So we now have about a 10-minute break. And
Sorry,
then,
may
oh,
I?
of
I
course.
just forgot to mention something.
It's
Since
your-
I still have
it's-
time.
The floor is yours.
Thank you. Now I just wanted to mention that I brought some t-shirts like mine. So if you want one, just come to me and we can talk a little bit and I will give you one. Thank you. Now I'm really done. Thank you.
Swag is the actual purpose of tech conferences. All right. So we now have a 9-minute break. Hopefully we have been persuaded that we should operate HA. Hananto is going to tell us how to maximize HA. Wonderful. Right, we are back on for a MySQL Master Principal Solution Engineer. Hananto, I won't try that. Hananto will do.
Wicaksono.
He will talk to us about achieving maximum high availability with MySQL. Take it away.
Okay, thank you, everyone. Okay, allow me to present about maximum high availability with MySQL to reach the most maximum system uptime for MySQL database. Okay, a little bit about me. I'm an Oracle database professional, basically 16 years Oracle database enthusiast, but 5 years MySQL database enthusiast, and I'm based in Singapore. So as we understand that MySQL can run on every server, any servers, including the commodity server. Therefore, our high availability solution is not using expensive hardware. We don't use shared storage, but we use a shared nothing architecture, meaning that we don't need expensive hardware to run MySQL on high availability mode. So we rely on database replications. As you know, that database replication is like a mechanism where every transaction that committed in one node will be committed also in another node, okay, using replication channels. Once we create replication channels on replicas, there will be 2 threads that actually running. The first is actually IO threads. The IO threads will actually load the data, load the transaction logs, okay, in form of bin log event from the source and put it in the relay logs. And IO threads, SQL threads will read the data in the relay logs and commit the same data on replica servers. So this is the traditional way how to create MySQL asynchronous replications. Basically, we need to create the replications users on primaries and then assign replication slave privilege to that user so that we can create replication channels on secondary node or replica database, okay, pointing to primary database using a replication user and start replications. The story complete yet. Because we want to provide end-to-end database solution for high availability. Yeah? So application need to be, we need to help the applications to do connection failover as well. Because replication meaning that we have more than one database servers running, and we need to mix connections from applications to be transparent regardless the database topology. So we come up with the InnoDB replica set. So InnoDB replica set is basically a modernization of traditional master-slave replications, okay, that we provide MySQL routers as a component to provide transparent connection failovers from the applications. And then we also provide admin API that we put this admin API on our tools, what we call it as MySQL shell. So you can use MySQL shell's admin API basically to easily configure InnoDB replica set. So again, this InnoDB replica set is based on asynchronous replications, but we have automatic transparent application failovers, connection failovers from the application using MySQL routers. So this slide basically talk about how easy to create asynchronous replication using admin API. Yeah, we can run the admin API through MySQL shell. Okay, configure replica in set instance is to configure the local instance prepare the system variables, and make sure the system variables is set up correctly for replications. And if the system variable is not dynamics, then the admin API will trigger automatic restart. But once done, okay, we do the configure instance on all nodes, then we can create, primary nodes of the replica set by easily, execute create replica set API command. So we can use admin API as well, okay, to view the status of replica set. Just log into MySQL shells, log into one of the database, especially the primary database, using MySQL shells, and then issue command status. And at this point, we have one replica set with one database running as a primary, and database is running as in read-write mode. Then, to add additional replicas, to expand or to scale up InnoDB replica set is very easy, right? We just run admin API at instance. Then, using auto, it will check the GTID of the new nodes. If the GTID is actually the subset of the replica set GTID, then automatically, incremental recovery will be executed. But if GTID is completely different, you don't have to do a backup restore in this case. If GTID is completely different, then admin API execute adding instance using MySQL clone. So MySQL clones will automatically execute it. Once clone's done, then it will continue with incremental recovery until the stage of the new node will be the same as InnoDB replica set. And we can view the status, okay? As you see over here, we are on the state that we have two nodes, one node as primary and the second node that we just added. Okay, it is running on read-only mode as a secondary node. And again, okay, MySQL routers come as a handy utility, okay, for connection transparencies. So the application can just connect to MySQL routers as database endpoint. If application connected to read-write port, it will connect to primary. Okay, if application connected to read-only port of the MySQL routers, then applications will, the connections will be directed to the secondary node. And to use MySQL routers is very simple. What we need to do is basically to install MySQL router binaries and then run bootstrap and starting up MySQL routers. So connecting to database, even though we have more than one, okay, database that replicating each other, yeah, in database in replica set setup, we just need to connect to the primary node. We just need to connect to MySQL routers, and if we use 6446, it is the default read-write port for MySQL routers. Then we will connect to primary node. If you're connecting to 6447 of MySQL router port, then we will connect to secondary node. And of course, MySQL routers have routing strategy. Okay, for primary connections, it is first available as a routing strategy. That means connections will be pointing to one primary. But if we are connecting to read-only port, then the routing strategy is actually round robin. So yeah, we will follow balancing the read-only connection across secondary node within the InnoDB replica set. And using InnoDB replica set is very easy, okay, to do a switchover. Okay, we don't need to activate or fail over the VIP, for example. Okay, we just need to issue command set primary instance if we want to flip to primary become secondary and secondary become primary. And application does not need to know about changing on database topology because what application need is just connecting to MySQL routers, and MySQL routers will redirect the connections to either primary or secondary depending on the port that application is using to connect to MySQL router. We are not stopping there, okay? InnoDB replica set does not, guarantees full consistencies, yeah? So in order to give a strong data consistency as well as automatic failovers, okay, we use additional plugin, what we call it as group replications. So group replication is the high availability engine that we are going to use for our cluster. I will explain later. Okay, group replications will provide the consistency or zero RPO. In this diagram, as you see, whenever application connect to the primary, okay, which is read-write, and making a transaction, and transaction is to be committed, then the primary will, send over the logs to all the secondaries for a quorum process. And the transactions will be committed if majority of nodes certify the transactions. Once the quorum is reached, okay, majority of nodes certify the transactions, its member will eventually commit these transactions to the InnoDB storage engine and so on. So we support up to 9 members. Odd numbers of members is preferred, okay, because we want to have majority members in the event of 1 or 2 nodes down. And then multi-primary mode is also supported, but with some limitation. Group replication provide automatic primary failover as well. As you see over here, we have 2 kind of clients. Okay, write clients and read clients. Read clients reading from the secondary node, write clients reading and doing transaction on the primary node. Okay, once the primary node is down, for example, the group applications will automatically point one of the surviving nodes as the new InnoDB, the new primary nodes, and the write clients need to connect to that nodes. Is it practical? Maybe, okay, because we're missing one point over here, which is application connection, failover. Therefore, we come up with InnoDB cluster. So what is InnoDB cluster? InnoDB clusters is group applications integrated with MySQL routers and MySQL shell. So MySQL routers over here is the same like MySQL routers that we use for replica set. Okay, that we can use these MySQL routers for connection transparencies. If the primary node down and primary node failovers to one of the other nodes, then application does not need to know, because what application need to do is just to connect to MySQL routers in read-write port, and connections will be pointing to the new primary node. And to configure the InnoDB cluster is very easy because we have integration with MySQL shell. We can use MySQL shell admin API to configure instance and create clusters. After that, adding a secondary node. And we have the same process as adding the new nodes into the replica set. Okay, we don't need to do a backup restore. Okay, because the admin API itself will triggers the MySQL cloning process. Okay, this is the high availability orchestrations against primary failures. Let's say we have a 3-node InnoDB cluster setup, application connected to MySQL routers. If the application connected to read-write port of MySQL routers, it will be connected to the primary. If the primary node fails, then automatically one of the secondary will take over the primary roles, and application does not need to know about changing on database topology, okay? Because MySQL routers will redirect the connections to the new primary node. And once the fail node comes back, it will automatically healing and automatically join back to the cluster. It will do incremental recovery or distributed recovery. Once that recovery completed, it will be online as secondary node in InnoDB cluster. So it is really, really automated and highly available. And start from MySQL routers 8.2, we add additional transparent connections read-write split. The application does not need to choose whether connected to primary or connected to secondary. Okay, application just need to connect to read-write split port. And depending on the statement, if the statement is DDL or DML, it will be executed on primary. If the statement is query only, then it will be executed in secondary node. So it is possible for OLTP application to split between read-write and read-only, right? DML, DDL with query only. The best practice is for OLTP, short query, short transactions, we need to think that all queries and transaction need to be happen on primary. But in certain cases, maybe on certain design, we might want to split the query, okay, to be executed on secondary. But the secondary node is not always getting updated at the same time as the primary. And we need to understand that sometimes a query on secondary node does not give us the new value that already changed in primary. In order to prevent that, we need to set group replication consistency equal to before. By setting to before, any query to secondary node where the data is already changed on primary, the group itself will decide that data is changed and commit, but the secondary has not commit that data, the query will be stalled, waiting for the data to be completely committed to the secondary. But it is good, because what? Because we don't want to change the whole data that already changed. So we can do this, set group replication consistency equal to before, either at session level, global level, or we can set permanently using set persist. However, sometimes during the operations, we are dealing with replication lag, right, on one or two secondary due to server utilization and so on. So we need to monitor the replications lag. If the replication lag is too far away, let's say 30 minutes, 50 minutes, and so on, waiting the query that we throw to secondary node and need to wait for that 15 minutes, I don't think that's possible for OLTP application. So what we can do over here is to prevent routers to route the read-only traffics to that secondary by using, again, MySQL shell admin API to put a tagging. Yeah, we can put one of the secondary nodes that lagging very badly as hidden. So we can monitor this. Okay, once these lagging servers are able to catch up, we can remove the tagging so that MySQL router will start to continue to throw the read-only traffics to that servers. So in order to make sure that InnoDB cluster can able to sustain against long-run queries, okay, and heavy query load, we can consider to add InnoDB cluster read replicas. The read replicas basically does not join inside group replication. So we can have MySQL routers, configure MySQL routers for any traffics, read-only traffics, to go to the read replicas. And between read replicas and the InnoDB cluster, there will be asynchronous replication. And this is managed by the InnoDB clusters itself. If we show InnoDB cluster status, these read replicas will be inside as a child servers, either on primary or secondary, depending on what we want. Some users basically wants to have delayed replications. What is delayed replication? Delayed replication is simple. Delayed replication is a read replicas, but we decide to delay the commit point. For example, for the last 2 hours, don't commit. Reasons why? Because if we have logical corruptions, when somebody actually truncate customer data, for example, okay, the truncate will be propagated, will be replicated across. So in order to avoid restoration, complete restoration of the InnoDB clusters, maybe it is good if we have a delayed replication, because the data is still there until the next 2 hours. Then the truncate will be executed in delayed replication. So we can put the data back logically. Okay, we can export the data and put back to the InnoDB clusters. Very simple. And then maybe ransomware attack that attacking our data inside the InnoDB clusters. Maybe we can use InnoDB cluster delayed replication. Yeah, delayed replication to recover data logically. And then we have a cluster to expand the InnoDB clusters to work on multi-sites. For example, if we have 2 sites, production and non-productions, disaster recovery, let's say, okay, we can use cluster set, and we also support admin API in our cluster set. We need to create one InnoDB clusters and configure that as a cluster set, and then after that, we can create replica clusters on disaster recovery set. Very simple, very straightforward process. And we can use disaster recovery site or replica cluster, okay, as read-only workloads, yeah, like ETLs, dashboarding, and so on, that does not require the new data to be, guarantees available over there, right? And same thing, if we have situations where the primary node is failing, then it will be there will be automatic failovers for the primary, okay, within the cluster. And this automatic. And then to switch over to disaster recovery side, maybe using traditional method, there will be a lot of things that we need to do. But in cluster set is quite simple because we just need to log in using MySQL shell to one of the nodes and issue command cluster set primary cluster to mention which cluster to be the next primary cluster. So there will be a role switch between primary cluster and replica cluster. And how about the application? Application does not need to know. What application need to know is router, IP, and port. That's all. Because the connections from application to MySQL routers will be redirected to the primary cluster. If there is a site failure, it's simple. Okay, we can do force primary clusters to promote the replica cluster in disaster recovery site to be the next, to be the primary cluster. And again, application does not need to know as well, because what application need to do is just to connect to MySQL router. And for achieving maximum high capability, we add additional configuration over here that we can split the networks between data LAN and the network that used by group application to communicate, each other within the InnoDB cluster itself. So we can have like network topology, something like this. MySQL routers and application running on application LAN. While DB LANs, we can split into two networks. One is data LAN, the second one is, I call it as private LAN. We can configure group application local address and group application advertised recovery endpoint to use additional FINIC inside the MySQL, okay, that pointing to another network segment. And this will improve high availability, performance, and stability as well. So in terms of InnoDB cluster set, okay, whilst we running multiple InnoDB clusters in our WAN, okay, this is the WAN routers, network routers, to communicate between production site and replica site. As you see over here, we have 3 node InnoDB clusters on production, 3 node InnoDB clusters as replica clusters in disaster recovery site, 3 read replicas, okay, to help the expanding this InnoDB cluster for lab, for example, or for heavy query, for example, okay, that routers can do a round robins, okay, to run heavy query inside, delayed replication on both sides and so on. And additionally, we can use a MySQL Enterprise Thread Pool that can help a cluster to run more scalable and stable. Yeah. So this is the summary. If you want to have to set up MySQL asynchronous replication, just simple MySQL asynchronous replication. Okay, we can choose to use MySQL as InnoDB replica set. It is basically just asynchronous replication with MySQL router support for connection transparency. But if we want to have zero RPO and automatic failovers, we can choose to use InnoDB cluster, because InnoDB clusters using group replication as HA engine and with MySQL shell, admin API to easily provisioning, to create, to scaling up, whatever it is, and MySQL routers for connection transparency. So if we want to extend InnoDB cluster to multi-site deployment, then we can, create InnoDB cluster set on top of InnoDB clusters, and we can start to build a replica cluster on a remote data center. Thank you.
It's been a while since I've had to think about the details of multi-site, but yes, it's all familiar. Questions, anyone? Yes.
Thank you. So you mentioned when there is an InnoDB cluster set, if the primary site fails, then we need to go and force the other one. Is that a manual process, so someone DBA need to make intervention, or it can be automated?
Since InnoDB cluster set replication is based on asynchronous replication, and we only have 2 sets, we can add a third set is okay, but we need to have witness to to make a decisions whether to force quorum or whatever it is, to force primary clusters, failovers, or whatever it is, right? But we don't have the witness. The witness is the DBA, so it is. But we believe that disaster recovery thing is not just one-person decisions. It is IT decisions. Therefore, it is very difficult to build the automations for set failover. But it is possible if you can create your own. Okay, put it in the cloud or put it in a third side to monitor the InnoDB clusters in production as well as on disaster recovery. If something happens, either to alert for the DBA to do force instance or to do some automations. It is possible, but it is not part of the product. Yeah, thank you.
Is that perhaps a bit of a line between HA and DR? They're not quite the same. You're crossing the line there from HA to DR.
Yes.
Yeah, that's fair enough. Oh.
Could you go back to the slide that you are dealing with replication block?
Which one? Sorry?
The slide that's about replication block.
Oh, replication lag. Okay.
So assume that I have a system that have high write traffic, and at the time I dealing with replication lock, and my primary node is fail. So could InnoDB engine provide how InnoDB the engine provide data consistency for us when that incident happened?
Thank you. Good questions. So zero RPO or data consistencies, okay, in InnoDB cluster is guarantees. There is no data loss. Even though you have 3 node InnoDB clusters, secondary 1 and secondary 2 all lagging, for example, and suddenly primary down, then the data is still on the secondary 1 and secondary 2. That's not the problem. Yeah. Because any commit point on the primary, it will require node 2 and node 3 to participate the quorum as well, meaning that actually they already received the transactions. So there is no data loss in this case.
Okay, thank you.
Thank you.
Right, we have, we can probably do one more. Last call, oh, right at the back, okay. No one at the back ever asks questions. That's great. Top.
Thank you. In one.
Which slide? You mentioned ransomware in one slide.
Sorry, I can't hear you.
Ransomware.
Oh, ransomware. Okay.
Ransomware.
Yeah. Nice. Okay. Yes, please. Okay. So ransomware attack is a cyber attack that does 2 things, right? The first is actually to steal your data, okay, and then broke your system, all right? In InnoDB cluster, okay, what in the database, right? If there is a ransomware attack, what ransomware is doing is basically to steal your data and broke your data, right? Corrupt your data, either physically or logically, right? Okay, physical is fine because you have a backup and so on, right? And you have, maybe replication and so on. But logical corruption is something difficult because what? Because we have replication, of course. Okay, anything that I do to drop your tables, critical tables, it will replicate it over, right? And it is very difficult to, to to recover from that kind of failure. And then suddenly all broken, right? Because the ransomware. So if you have a delayed replication somewhere and we protect the delayed replication in other segments with network firewall, all those things, it is possible that your application data that inside delayed replication will not get affected by a ransomware attack, because even though the transaction logs already received by delayed replication, but it's not committed yet, waiting for the next 2 hours or 1 hour and so on, so that you can have your data clean over here. Okay, thank you.
A critical question in ransomware is recovery time. Recovering in minutes instead of days is really valuable. So yeah, that's cool. Thank you so much.
You're welcome. Thank you.
We now have a T-Rex sponsored by Penpot. We'll be back
at 11. Hope to see you then. Thank you.
Thank you very much. Thank you, everybody. It's a pleasure to be here. I'm going to, unlike a lot of the other more deeply technical sessions, I'm just going to talk about everything that's going on with MySQL in the more recent time. As my safe harbor statement indicates, a lot of the things I'm going to talk about are going to be in preview, in beta, or have just come out. So please, before you say, I'm going to download that and start using it, please read the state of what's going on in our announcements, our blogs, everything else. But to start with, I'd like to say that pretty much all of you have already interacted with MySQL today. If you guys have used a social media network, if you have booked a car, or maybe gotten a house, or rented a house or a hotel room or something like that, odds are it's gone through a MySQL database. And of course, as developers, you probably know that we are the thing that powers most of the major open source platforms that are out there today. And we continue to do so, and that's one of the things we're very proud of. I'd like to talk to you about some of the future direction of MySQL, the product that you can download on your laptops, as well as the product that we are very proud of that we run on the major clouds, and it's called HeatWave. So HeatWave is a managed MySQL service. It's the MySQL that you're used to. It's that same interface, the same SQL interface. However, it's also got a number of interesting parts that, for the most part, only can exist in public clouds. HeatWave itself, as we originally introduced it, is an in-memory columnar storage cluster that you can attach to a MySQL server. It runs in OCI, the Oracle Cloud, as well as in AWS and Azure. What we've added to that in the last couple of years, and some of the things that I'll be talking about, is in-database machine learning. So you can do machine learning without having to use TensorFlow, without having to use Python or R, right inside the process of MySQL. And I'll talk about why that's important. And also, we have something that we call Lakeouch, which is that MySQL, or HeatWave, is capable of reaching out into the object store and grabbing CSV files, Parquet files, database backups, Avro files, and incorporating them into that in-memory columnar data store. So you can have 0.5 petabyte of data that you are querying in real time across 64 nodes that are attached to your one MySQL database that you have up there. So it gives MySQL an enormous amount of scalability. So in addition to that, we've kind of changed the release model. We've introduced some new developer tools. We've introduced JavaScript into the engine. In short, MySQL, I'd like to talk to you about some of how that impacts you and some of the things that are coming up, and it's a lot to cover. So the first thing, as I alluded to, is that we've changed the way that we release MySQL. A few years ago, we went to what we called the continuous innovation model to be able to roll out new features more quickly every couple of years as we released new major increments. And that was great for a lot of the social media and a lot of the cutting edge companies,
but it was really for, we have a lot of banks that run MySQL and a lot of governments, and they don't really like fast change. So what we've done is we've tried to give everybody the best of both. We have what we call the innovation releases, and that's these little boxes that you see rolling up. The innovation releases are the latest and greatest.
We support them until the next innovation release comes out, and we put all the new things in there. So some of the things that I'm going to be talking about when I talk about our vector data type, when I talk about JavaScript stored procedures, things like that, those are going to pop up in these innovation releases. And then every 2 years, we will come out with a long-term support release. If you use Ubuntu, you're very familiar with this one. So you have to decide which one is right for you. So basically, when you're developing, when your application is in active development, you should probably be going with the innovation release. You should probably be getting the very latest things. But then when you go into production, when you're not going to be changing your application, you don't want your application to change everything. So for that, we have the LTS release, and the LTS release for its entire 8-year cycle, and the standard Oracle support cycle. For 8 years, you will get nothing but our bug fixes, our security patches, and none of the behavior change. We won't introduce new keywords, we won't create new functions or change the way that functions work. That may mean you don't get some of the performance increments that we put into the innovation releases, but you get stability, which most people would agree is important. Now, while you're doing that development, you might have heard Hananto talk about the MySQL shell, which is our new command line client. It is very exciting, and we've actually integrated it into VS Code as a VS Code plugin. So you can use MySQL shell, which replaces the old MySQL command line client. You can use MySQL shell as a command line client, or you can have it be something that you have built into VS Code. So you can have it be the way that you are inline integrated, you're writing your SQL code in line with your JavaScript or your Python or your C++, and you can still edit it, still have all the syntax highlighting, and still be able to execute against the database. But then the other thing you can do inside of VS Code is that actually, if you're using our cloud offering, HeatWave, VS Code will actually create a bastion for you up in the cloud so that you can get through to a database that has no public IP address by virtue of using your cloud credentials to log into the cloud, create just kind of an invisible bastion host that then is able to connect to your MySQL database. So it's a much more secure way to develop from your laptop onto a cloud server. And then, of course, once you're developing, you can do your administration of that server. You can see the server status, you can see your network status and all the things that are going on inside it from your laptop, from inside of VS Code. So it's a full-fledged development platform. And again, VS Code, this plugin is open source, and as is MySQL shell. So the next thing I'd like to talk about is that we've added a new feature. Again, this started out in HeatWave, and it's soon coming to the downloadable versions of MySQL, where you can actually write stored procedures in JavaScript. So what that means is that these JavaScript stored procedures have become a native part of MySQL. So you can use them inside of your where clauses, your order files, and things like that. So now you can embed JavaScript into your SQL. And then when you're writing these things, you can embed SQL into your JavaScript. So when you're writing these stored routines, you can write them and then add in what you want them to do inside SQL. So you have this way of combining procedural and declarative languages. The way that we do that is with Oracle's GraalVM. So GraalVM is actually running inside the process of the MySQL server. And it is able to, it's got multiple language runtimes in it, but the only one that we included for the sake of space right now is the JavaScript JIT compiler. So now, going from development into the clouds themselves. MySQL HeatWave, so again, this is just kind of our definition of the MySQL HeatWave database service. We are the people who wrote and maintain MySQL. Whenever you see MySQL open source database, they're talking about the thing that Oracle produces. Everybody else makes their MySQL open source because they're legally bound to. So we have a GPL database that then we use to create cloud offerings. So HeatWave is our version of MySQL that runs as a managed service, so fully managed. You don't have to do anything to administer it, to back it up, to increment the versions, to apply security patches. We manage all of that for you inside of Oracle as well as the Amazon Cloud and the Microsoft Cloud. And this is all based on the latest version of MySQL, obviously. And then it has all the things that we have that I've been talking about, Heatwave, the first of which is this columnar in-memory analytics database. So what this is you have your MySQL database, and then you can have from 1 to 64 in-memory nodes that you just spin up on demand. So if you've got a lot of data and you do a lot of processing, if you only do your analytic processing in the last week of the month, you don't have to have a massive database that is always existing and you're always paying in the cloud. You have your regular MySQL transactional database, and then when you're going to do your analytic processing, you spin up 1 to 64 of these nodes, and each one of these can be of different size as well. So you can have half a petabyte of data in memory in the cloud. And you can do your querying across that. And if that sounds fast, it's because of this. By our benchmarks, which you can redo, these are standard TCPH benchmarks using 500 terabytes of data, and these are the results that we get across different database systems. So it is lightning fast. We think it's the fastest way to do analytic processing. So then, in addition to being able to do these analytics, what else did we find that people wanted from a cloud database? So one of these is, so the first one obviously is being able to do large scale analytics and to be able to speed that up on demand without having to, as I said, spend a lot of money on a massive instance that is just always existing. The next one is to leverage machine learning without having to move your data anyplace and without having to hire a large team of data scientists. Not that there's anything wrong with a large team of data scientists, but that shouldn't be the gateway to doing machine learning. We've tried to democratize the process. The next thing we want to do is to be able to use your data wherever it is. So you can reach into object stores, as I said, in Lakehouse, and you can pull out that structured data for use for analytics. So that your CSV files, your database backups, things like that, you can pull out for use with analytics. And actually, as I'll talk about in a couple of minutes, if you have data that you want to do AI summarizations on with an LLM, you can actually read that as well. You can read unstructured data, again, not into your schema. You can read unstructured data into the database for use for RAG and other things with large language models. And again, just put this on a slide in case anybody missed it. It does run on multiple public clouds. Heatwave is, if we develop it at Oracle, but it is developed and optimized for multiple clouds. So a little bit about machine learning. So we have AutoML, the idea of which is that there's a lot of steps. The data scientists in the audience are going to recognize that machine learning is not easy, especially if you want to be able to explain the results that you've created. You need to be able to understand exactly what your code is doing and exactly where the data came from and went to. And there's a lot of different ways to do that. Just if you're not familiar with machine learning, the way that I always think of this is that, let's say that you run a bank. A customer comes in and you want to determine, you know everything about them, you know all your other customers. You want to know, should I give this person a loan? That's a classification problem. Machine learning can do that. As long as you have that data in MySQL, we can show you how to do that relatively quickly. Now then, once you decide you're going to give them a loan, you say, okay, well, how much is that loan going to be for? That's a regression problem. And machine learning can also do that. And then you're going to want to give them the schedule. How soon can they pay it back and how much do they have to pay? That is a time series forecasting issue. Machine learning can also do that. You can still do all of this in And then once you've done that, you want to make sure, oh, wait a minute, is all this information correct? Does anything look like it's completely out of order? Well, that's an anomaly detection problem. And again, you can find out, did they put an extra zero on the value of their house? Did they not put enough zeros on their salary? Does something look like it doesn't add up with the rest of the data? Machine learning can tell you that as well. And then finally, once you have the successful customer, you can say, well, what other bank products might they want? Well, that's a recommender situation. That is also something we can do with machine learning. And again, you can do this not just with all the information that you have inside of your transactional database,
but it can reach out into Lakehouse. If you have another database backup that has prior data from other loans that you've given, or other products, or something like that, you can pull that into memory, into your online HeatWave nodes, and you can process that as well. And I realize this is kind of a survey talk, so if you don't understand the details of any of this, go ahead. But we've got a lot of speakers here, and I'm not going to tell you a lot more about this. But as I said, we're democratizing machine learning, and the way we're doing it is that this is all you have to know. All of our machine learning inside of HeatWave is controlled by just these stored procedures. You learn the parameters of those, and you can do all the things I just said, as long as you've got the data. And then since we went ahead and built a machine learning engine inside of HeatWave, we also use that for HeatWave. ML Autopilot is the system by which our machine learning engine watches your queries, watches how the optimizer does things, and then improves upon them. You can also ask Autopilot, should I add, based on what you've seen of how I'm using my database, do I need more indexes? Have I written indexes that I don't need? Autopilot can tell you that as well. Autopilot can also tell you in the cloud, would I benefit from moving to a larger shape? Can I use more CPUs? Or am I overpaying? Can I shrink down this to a smaller shape and still get exactly the same performance? That's also something, that's also one of the benefits of having machine learning built into it. So then I have to teach you, this is, again, one of the things we're working on, and I would encourage you, if you look at our Open Cloud World Tour, our head of engineering, Luna Barwal, has been doing talks extensively what we're putting in terms of artificial intelligence. But the basics is that, as I said, HeatWave Lakehouse can read things out of objects. So you can read unstructured data and then ask the generative AI that is linked to your HeatWave database to summarize it. You can also take that same generative AI that is linked, and you can use it as a RAG system, retrieval augmented generation. And it's a lot to summarize, but basically what you can do is, if you have data on your recent press releases, for example, and you want to say, and you want to ask an LLM, hey, can you generate an answer of how somebody can use this brand new feature of MySQL? The LLM might have been 20 years ago, so it might say, I don't know what you're talking about. So you can point it to these PDFs or documents that have your recent press releases, and you can say, okay, using these, now, when you mention the question, that's the basis. It's somewhat more complex than that, but that'll be for now. And then you can do all that with natural language. You can actually ask the question and then have it deliver an answer that is also in natural language. And so the key to doing all this is, as I said, we're introducing a new data type that is called a vector. A vector is kind of a semantically meaningful numeric representation of a statement or a word. And with vectors, you can do semantic search of documents. So you can return just the relevant parts of documents, and then use that again to feed and So you may be wondering, if you're familiar with LLMs and RAG, you might be saying, well, why do I want that in my database? The reason is because if you have a machine learning engine already in your database, then you're already very capable of narrowing down that search space. You're not asking a completely open-ended question, which is the hard part of this, but you're basically, you can use machine learning to narrow down exactly what you're asking the LLM to do. And then, because it's a database, you can provide data. So this winds up being something that is very important to have all connected into one place, and we're going to build more as time goes on these signatures. So just to wrap up, and then I'll try and take some questions. This is MySQL HeatWave. It is all based on the open source database that you know and love, and it has several parts to it. It is obviously a transactional processing, maybe the thing that processes the most transactions in the world. It also does analytics up to the petabyte scale. It has a machine learning engine inside it, and that machine learning engine can also make it smarter. Thank you very much.
context, before I take Q&A, is the next speaker in the room? No, we go ahead and set up before we do some Q&A. Please set up your laptop now. Thank you. Right, do we have any questions? Okay, Joel.
I see that you said that the way is on the cloud, but I didn't see you mention Google Cloud platform. Is there any plan to integrate or do you support?
As of today, it is not in the Google Cloud, just the three that I mentioned.
One more question. I see that the heatwave is almost out. So is there any just a case for us that with configuration we should do just a mission recommendation?
Just to have a recommendation engine?
Because I see that this way is do a lot of autonomous things. So as engineering on database administrator, I want to iterate and give me some advice or recommendation for configuration.
Oh yeah. Autopilot heatwave. So yes, autopilot will give you, like I said, it does index. It'll evaluate your index. It evaluates and adapts its own optimizer, and it'll also tell you what shape, if your shape is ideal, as well as doing a number of other things with the Lakehouse too. Sure.
One more question.
Sure, of course.
When we talk about clouds and requests for clouds, databases for clouds, I think every time about hardly needs, which usually can change only if you start. Likewise, shared memory size, blocks, maximum number of blocks, for example, maximum number of backends, workers, and so on. It's painful in some databases, specifically for MySQL system. In MySQL, this problem resolved, you can scale up and scale down such hardly needs.
There's a lot of things you can scale. We've got some engineers who can talk about the specifics of what is easy and what is hard. Being able to scale your number of IOPS is a little bit challenging in the cloud once you've already set up your storage system. However, actually changing the shape, being able to say I want to go from having 2 processors to 16, that you can do. You want to change the amount of RAM that you have, things like that, and obviously changing the database parameters.
We can probably do one more. Okay.
Thank you. So the autopilot doesn't only work if my schema is on Keepwave. Yes, I'm using MySQL with Keepwave. The autopilot works.
Yeah, autopilot and all the machine learning things, those are part of Keepwave. Yeah, that's part of you can't download that.
We can't use it for optimizing schema, let's say the dump schema from regular MySQL.
Yes, you can certainly you can replicate your schema from on-premise up into the cloud and use autopilot on it, or you can just do a dump of your database, restore it into HeatWave, and do whatever you want to do, and then obviously take the recommendations that it gives you, and then turn on HeatWave. Yes, of course.
Thank you very much. Thank you all. Pause for about a minute and a half. And start next talk.
Okay, so next up we have Phasupong, who is a principal MySQL.
Yeah, thank you very much. Hello everyone. Principal Solution Engineer from Thailand. On this section, I would like to explain on the high level of the document store feature, how to deployment the load of technology, NoSQL and relational table inside of the MySQL technology. Before we go inside of the feature, I would like to make understand about the JSON data. What is the standard? JSON is come from the JavaScript object notation. It's the default standard with the RFC 7.1.9, and its structure includes the object array and visible in the example. Why popular? Because the developer is friendly with the JSON document. Simple to define the application. You don't need to define the schema or the data in the beginning. You can work with the JSON in the beginning. Easy to implement in the initial of the project. And then this have the ability of speed when you deployment with the application with the JSON document. And after that, when we have the JSON-centric document database, its adoption really popular in the currently. Since MySQL 5.7 integrated with the JSON feature, we can utilize both of the relational table and JSON data inside of the MySQL database. You can work with both of them or do it simply. Some applications need to query output of the JSON from the table, and some applications they would like to integrate data to be JSON and original table. How to be with when the database template which will be the technology of the NoSQL and MySQL. It's easy to integrate data with the MySQL technology. And the next one, after we put it in MySQL 5.7, we have some features like start native JSON data type inside of MySQL database. This is the binary format inside of the database. You can define the data type of the binary of the JSON document. And we have the document validation. When you insert the data, but the data is not a value. When you insert the text cannot insert the value. We can do the validate data before you insert the data inside of the document. JSON inside of the MySQL. And we built in JSON function for helping you utilize the SQL syntax with the JSON. You can extract data from the JSON with the SQL statement. And another one, we can include the letter of the database by adding index in the document JSON. And then when we indicate the syntax in the SQL statement with the data document, I will have this next slide for sharing how to working with the SQL syntax and the JSON function. This is the JSON function we have on the MySQL. You can put it on the SQL statement for creator, modify, and insert JSON. This can work with the similar one with the SQL statement that is and all the details of the JSON function you can go inside the website. They can explain more detail about each function of the JSON function. This is an example how to use the function of the JSON with the SQL statement. On the left-hand side, you can create the table with the JSON data and insert data in the JSON document, right? And when you select star from employee, the return of the result is come from the JSON structure.
And then when you need only the name on the JSON document, you can put the JSON function, JSON data name, the result we use the result only with a simple statement. And this is a show how to improve the performance with the JSON document by add the index. When we need to improve index with the feature type, add the feature in the document function, you can add the index and do the select for the function this one. The optimizer of index, let's say index definition for this selection. It's easy to modify and add the index for improvement of the database. In the MySQL, we can do both of things about the DDLs and NoSQL. Normally, before we join, we have the both of the technology inside of MySQL. We have to separate the database, and when we do separate, the data is quite different structure. Sometimes application you need to list out of the table relation to be the JSON document to work with application. And it's the same thing, but the different structure between the relational module and JSON document module. This is how to see the data between the DBA and developer see data in the JSON document. It's a different thing. Before we have the document store, we have the one technology with the MySQL and another technology with the NoSQL data store. The both of the technology work separately simulate data store on each technology. And when the developer or business user need to integrate the data between the MySQL and NoSQL, it's difficult to do integration. You have to deploy data DDL to integrate all the data to be the data warehouse and get the report from that. That's the difficult thing to integrate the data between the relational table and JSON document. Now we have the MySQL. We can store data as the relational table and JSON document inside of the MySQL. That MySQL document store, we can do hybrid both of technology, SQL and NoSQL. And application can integrate only one database and return result of the both of technology to the application. And the result of the application, you can select data with the relational table and get result with the relational and data between them. And you can get the data with the relational and output with the data document structure. And and also we can get the data from the JSON and get the result with the relational and JSON out in the same way when you connect with the MySQL technology in one database. After we put both of technology inside of MySQL, we can have the power of SQL for access the data. You can access the data with the relational table and schema JSON document by SQL statement with the MySQL. And we put some technology in the application. Maybe you can deployment with the InnoDB cluster and cluster set for the NoSQL in MySQL database. And the next one, data currently we compile with the ASIC for the data consistency data. And for we indicate both of type of the technology inside of MySQL. Of course, we will reduce the effort and cost for managing the database. When we have a lot of database inside of the company, we have a lot of the DDA, we have a lot more costing, we have more knowledge for managing the database inside of the company. And if we have this integrated and contain or all of the technology is reduce effort and cost. Yeah, this is the diagram about how to access the data. The application can access with the MySQL connector in the simple one to standard protocol access the data. And some when you need to access the NoSQL, you can access by the X protocol for access the NoSQL. In terms of you use the MySQL shell for access the NoSQL for manage some structure of the NoSQL database. This is the benefit of the people company. Some people in the developer department, you can get the benefit of the data can use with the schema lake and document model and work with the partition in the table as well. And in terms of operation, you can improve the command with indexing for improve access the data inside of the NoSQL statement with the indexing. And the last one you can manage and visible with the one database by to the replicate, backup, and restore with only one database. And simple application schema update in only one database. This is the way for get the data result from the board of technology. Some applications they would like to get the data in the JSON format. You can send the selection to the relational table and put the function of the JSON object. The result of the selection will be get the data in the JSON structure, and application can use the mouse of the JSON JavaScript for access the data like this. And the next one, when you need to combine the data between the relational and document, and send only one statement for relational between the table and JSON table, and you get the data relational between both activities. Sometimes in our customer they put some web application log in the JSON document, and we have a customer table in the relational table. How we do the marketing attack to customer with the web application e-commerce with application log. We can do a relational table between the table and JSON document that keep the log of the application log. It's an easy way to do on the MySQL technology. If we don't have this technology, we need to implement some ETL tool for integrate data both of technology and do relational in the another table. This is an awesome feature for querying the data. Sometimes we would like to get the top 10 of the restaurant, but the data is come from the JSON document. And you can use the select length of the selection statement for the ranking of the table of the restaurant name and the food of the restaurant. How which one is the number one and top 10 of the restaurant. You can get the data from the JSON table and get the ranking from the statement with SQL. We can combine all the technology access the data JSON document, and we use the statement for get the ranking for the statement. We can combine both of them to work together. On this way, you don't need to have to another technology to get data outside, and the management level of your property is easy to access the data when you have many type of data inside of the database. This is an easy way to access the data with the JSON and use the statement for get the ranking of the data. This is another one we have. We get code to work with MySQL. You can download extension and can work together with the VS Code. Before we have this one, we have to work with IDE, right? IDE tool for development application. And when you need to understand the structure of data, you have go to another tool for understand structure and come back to another tool to development application. On that VS Code, we can download extension and get the SQL for access the database with the MySQL shell. And then we understand the structure of the data, and then we can use the REST schema from Schema database for create the database. And we come back to the development mode. We can get the data from the REST service that we get from the SQL mode. And then we can come back to show the table again with the SQL mode. And we can we can do the edit some structure on the table on the SQL mode, and then we can come back to TS for get the data again. This is a we can work both of application development and database structure on one tool. This is a VS Code. Okay, before I have some information to share you. Actually, on YouTube, we have MySQL channel. MySQL channel, we have a collection of the video for you learning in the future. You can go down and select some video you would like to study in the short one. Number 4, you can create the new MySQL Document Store on that thing. And you can click and you have the step-by-step development and then use the document store in the SQL MySQL. This is you can do the self-learning on MySQL channel on YouTube. And we have the MySQL.com for access any information about the MySQL feedback, MySQL partition, cluster, and OEM. This is my presentation for the document store. Any questions?
It's excellent to have the problem of finding more questions than just to have to walk a stick on the stage. So, nobody here has had to work with the separated relational and document before? Yeah. Shame. I found it useless in the past. I don't think that can even find structures in the DDLs. Just let me run through. So that being the case, we have a 12-minute break for our next speaker. Thank you very much. Alkin, can you? Okay, next up we have the first of two talks on ClickHouse. First up, Alkin from Just Data on ClickHouse.
Okay, I can continue. All right. Hello everyone, thanks for joining this talk. Today we're going to talk about ClickHouse and some real-time analytics ideas and use cases and how we can leverage the open source tools. So let's get started. My name is Alkin. I'm from Istanbul, Turkey, all the way. And you can connect me via LinkedIn and if you have any questions. I previously worked in services companies like MySQL, Document Store, as a technical person as a DBA. And in my previous life, I was an enterprise DBA. I also worked with large corporations like AT&T, Bank of America. And if you can connect with me on LinkedIn or have questions, or connect with other people that have connections, please feel free to send me an invite. This is where I work. It's Sys Data. Some call it Chista, some call it Sista, some call it Sista. It's founded by Shift and backed by funding. And we focus on infrastructure, maintaining of ClickHouse, and supporting services with ClickHouse. So what's the ClickHouse anyway? We'll talk about it. Has anyone heard about ClickHouse in this room? Okay, there's no time for so never heard of ClickHouse before? You never heard of ClickHouse before? Okay, you heard of it. You heard that it exists. We'll talk about that in a little bit. Alright, there are some recognitions here which I want to touch base at the end. And we started very time to it. Why is that? Because I'm a captain, I always do this, just break the ice. And my question for today to this book is this: what is the term for the process of turning a sailing vessel towards the wind? Anyone? So not towards, away from it. So because the sailing vessels cannot go against it. Good one, good. Okay. Yeah, it's called tacking, and some call it jiving, but we never sit because you'll be blown away, and that will cause a matter of one situation. So we also call it thermal, which you can actually do one, then the other one, start on port side, start on port side. That's where you can actually zigzag against and go against the wind. Right, ClickHouse. Back to work. Enough fun. And ClickHouse is open source. Apache 2.0 license is important. There's a bunch of licensing sources around. Open source database management system designed for analytics and workloads for all. And it is intended for non-traditional data warehousing systems for real-time analytics and doing much more beyond the traditional systems. So we'll dig into those. The other highlight for here is it's a colder storage model, which I'll touch base on this, what is the difference between. So this is the MySQL track, but yesterday it was a Postgres, it was a role-oriented relational database and systems which we are familiar. They are targeted audience for transactional workloads. And normally, say you have a customer table and you're role-based, and when you select from a customer table, you actually do by role and access the data. It has benefits, pros and cons to it, but it is highly recommended for the cap theorem, consistency, availability, and partitioning. So it actually enables these systems, enables asset properties, and it's role-oriented. So when it comes to OLAP, we have a column-oriented systems which are emerging, and they seem to be working faster and better for workloads that are intended for BI analytics. Nowadays, it's more machine learning, AI, which we actually did a talk on the heatwave, which covered the generics of it, won't go into this. But each column is a separate file, and then it's with the role set. So you still make a connection like you do it on MySQL, and you'll select. It will still return the data, but the way that it stores in the file system the way that it accesses is different than the role-based systems. In MySQL, we use InnoDB, we use B3 indexes, we use row IDs to access the data, and then delete records to do it. But in ClickHouse, it has its own system for searching multiple columns, just it accesses the columns that you need. So again, in the OLAP world, you may have columns that are not practical for row-based systems, which we are facing right now, tables with hundreds of columns in them. And then we can select the ones we want. There are very nice visual representations of these, but I'll go with the old-fashioned way because I'm an old-fashioned person. So actually, when you want to call on it, you can still make the select as the previous MySQL interface. So this is another thing with the familiarity with ClickHouse to MySQL. MySQL wire protocol and MySQL interface is very similar. So at the time of implementation of ClickHouse, that was I won't go into the history of it, but there's a lot of similarities how you access the ClickHouse server, very similar to MySQL Postgres. So you don't actually have to reinvent the wheel. You can still make a connection from a CLI and use the standard SQL. So this is another highlight which I can just summarize at the end, but a lot of the modern analytical systems have their own language or access methods and functions and things like that. It's not very good for programming or automation. So ClickHouse enables us this command line interface looking like any other RDBMS is making it also usability and use case like that. So we said analytics, we talked about a little bit on data warehousing, all that stuff. When it comes to data that can be accessed immediately, it makes a huge difference. And we do that with leveraging ClickHouse on getting a strategic imperative, competitive advantage, improving efficiency, and customer experience. Of course, this will all return to your revenue. So let's take a gaming example. And you have a game. I don't know who are the games in this room, but I'll tell you a little bit as time purpose. Say you have a game and you play online, and the gaming platform, whether you're on a PlayStation or mobile, use leveraging these technologies and actually taking advantage of what is happening in the game, what the user activities are, and suggesting you to buy something. So I play Call of Duty on PlayStation 5. Every time I do anything, go in and out, it suggests me something that is related to my playing time. And this is only possible with this system like this, and it turns into basically. Otherwise, you will have in your own small base, you will have one game, start playing until the end, and you get out, and what you pay for is there. Because there was no real-time analytics. So think about this way. There are many examples like that. Whether you're doing in crypto, whether you're doing something online, the last things that you looked on your e-commerce site or your online web store, it will make suggestions. And those are only possible by real-time analytics using these systems. And I worked in many e-commerce sites, and we didn't have these technologies at that time. They were emerging, but we didn't have the volume or the needs. What would happen is you would have the data that would run an ETL overnight, and the next morning it would be available, go into the DDL system with a CDC, chain data capture, and then you would run your reports, and that suggestion engine would go into the user's profile. In this case, we can make this possible real time in the sense that it's real time. And today's technology allows us to get to sub-minutes real time in some cases in seconds. So going back to ClickHouse, how you can do this open source, and you can basically do it on your own server, give it a try. But when you try ClickHouse, you will get a couple of things out of the box. One of them is efficient compression. So it has default efficient compression as before. Basically, say you have data in MySQL or Postgres, you dump it into the ClickHouse. You will get like a gigabyte file into 250 meg, because it will compress automatically, it will store it in the file system, the same data this is one of the surprises people actually see this. Is we tell them, okay, how much data are you maintaining in your MySQL? They say, well, we have about like 2 terabytes. We calculate how much goes to storage in cloud or on-prem. And then they say, no, this is going to be only like less than a terabyte because once we load it in ClickHouse, you get the default compression. You don't need to do it. But actually, you can use advanced codecs and mingle a little bit around depending on the data type and the data column type, then you can actually get even higher compression ratios within the data set. Vectorized query execution is another one. It actually has a batch system. Internal engine actually works very optimized for this type of workload. So you get CPU. CPU in the cloud is not that expensive as compared to IOPS network or the storage, but it's still a thing. If you're running a machine learning workload or heavy GPU workload, you want to take advantage of what you're running because that will save you some money compared to the CPU efficiency. So scalability is built in horizontal sharding and replication, which is difficult to get out of the box. You can customize sharding based on your index type, and then you can split up the workload in a smaller node, which will save money and time, and also allow you to scale. And also, there's an option for replication. Not super common for higher limits of a lot of workloads because you might be running a petabyte scale data set that may not be suitable, but it's there. Some is a requirement, is this requirement? Some is a demanded by the government or something like that. There is a replication. Very rich functionality and built-in, especially aggregation. So modern SQL has aggregation, but the functions are heavy and costly for the other RDBMSs. So ClickHouse takes advantage of these functions where you actually run queries against a large data set to get a summary data. So it also has support for geospatial, which we had a session yesterday on PostgreSQL, MySQL supports GIS also with functions, but you have that also materialized views and the as-is SQL. So these are very important things, like when you actually have data that's feeding in, and you have a materialized view on that, what you want to select off of it, and then you can create basically a mini database within a large, very extremely large database that you can actually pipe it later on to another analytic system that can actually create a, say, a dashboard or a leaderboard, things like that, only possible with these systems. And if you want to run that on MySQL, you won't have a problem when you need to volume. Benchmarks, there's a very extensive benchmarks, which I will not go into this one because we don't have enough time. ClickHouse has its own benchmarks run against any other database, including RDBMS and other databases. We have a benchmark suite for our system. We are running continuous benchmarks on everything that we touch, every server, every version, every platform we can actually have an access and compare with others. We are actually ahead of the curve when it comes down to that. The only thing that beats ClickHouse benchmarks, if you spend thousands or millions of dollars on the cloud, and you can get some of the other TCP/TCP/T benchmarks. You will actually have reached those, but those numbers are so high that no one will want to do that or even run it and run for their life if they see the bill of the cloud consumption. I have seen, so if anyone wants to talk about benchmarks, I have seen the numbers grow so exponentially after certain IOPS and storage allocation in the cloud that it's not even feasible to run the benchmark, yet you run a business to get the profit off of it. So we can have a discussion on that. ClickHouse is an engine family similar to MySQL, so it's that they're pluggable engines, and there are engines that are built in. One of them is a merge tree. Merge tree works like an LSM engine type, and that's the most common one. And merge tree engine family has dedicated engines for certain operations, like a replicated merge tree that does the replication for your tables. And you define that like a MySQL, say, engine merge tree, and then it will actually go into that engine. There's a more lightweight engine. This is made for the log files to be stored in ClickHouse, so you can actually create a table with this type of engine. And there are integration engines that I will show how you can actually coordinate around the open source ecosystem. So the integration engines goes from, of course, from MySQL, Postgres, RDBMS for the open source databases, where you could push the data into ClickHouse. But also there are some other connectors like ODBC can connect into anything, including SQL Server. There's Kafka, which I'm going to give some examples of that. RocksDB engine is known as a plugin engine for MySQL. It's an LSM engine that is also used in large hyperscalers like Facebook. And you can actually integrate that data. And there's other this is like in summary, there's like much more to that that you can make integration. So basically, if there is data, at the end, there's ClickHouse. Okay, the sample integration on the MySQL, very high level. Not going into too much detail, but we can talk later on. Say we had a customer table we selected. I didn't change that. Customer table is not a good example for analytics because it would be probably a reference table for orders and items and everything that the customer does. But say we have a customer table with customer ID, etc. And then you actually want to take that table and put that into ClickHouse. You create that table in ClickHouse, saying that engine is MySQL, so you connect that table directly from the source table within the ClickHouse interface. And once you create that, you're in ClickHouse to load that data by selecting from that table. Basically, you hop a staging table, and then basically you can get that table imported into ClickHouse in these like 3 steps. It'll take 3 seconds to do it. Just if you want to test something, say you have a table. Once you get that data, it's not intrusive to the source, so source can stay in production, source can be sourced, and you're not touching it, you're in ClickHouse, then you can play around, see what you can do with it, create dashboards, whatnot. And just to give you a quick example, that table, this is from my laptop, by the way. It's a super local. That table, customers table, was 34 megabytes in my laptop. It's dropped down to 13 megabytes in ClickHouse by default. So I didn't do anything. Only thing I did was select it and insert it into ClickHouse table, and it turned into like 13 megabytes. So you can do this. We get approximately the same as the form compression, even on a Mac. So think about what you can do in production. Okay, so let's talk about the ideas a little bit one more time. So analytics on denormalized table. I will give you one hint about this. When you want to put the data from your OLTP platform, you want to denormalize it because then you can actually have advantage of it in the long run. For example, we gave customers orders items. You want to put customers order items into one single table with the multiple properties without duplicating. You will be able to have access to the columns that you need, amounts they spent, the activities they did, categories they used, things like that can be. So the other thing is a star schema. You have a customer, and then you have the surrounding tables around it. So very useful use case for the ClickHouse implementation. You can import the historical data that is, for example, not used in the. So the idea is, the main idea is getting into the systems is to make your production environment leaner, smaller footprint and faster server for the RDBMS in your RTP, but the OLAP can be migrated. So you can actually get the time series data, log data, everything that is not necessarily sitting in your Postgres or MySQL should be here and pointed to this database instead of that database. That will make your all the talks that today was high availability, failover, disaster recovery will be much easier if you have all data into ClickHouse instead of MySQL or Postgres. So those are the ideas. All RTP archive, the same thing. We are archiving something that is not needed or required for the governance. Anything over 7 years, anything over 5 years. I still want to have access to get some analytics, but I don't want to keep it on my production. Put it on ClickHouse. Data lake and traffic solution. I will talk about this in one slide. And observability. Actually, there's a lot of observability things are going on. Yes, we collect all the data. There are so many waits events. There are so many triggers, activities being captured. and how are you going to store that? This is the way that you store it in ClickHouse system like this will be super useful. There are links at the end of the slide deck with open telemetry, how you can actually keep all that good information and turn it into a useful activity. So for the real-time analytics, there is a product, open source product called Debezium. I don't know if anyone heard about it, but Debezium Connector is an amazing open source framework that can connect to multiple databases. So these are examples, but Debezium supports other databases also. And with Debezium, you can basically reach any database. With that framework, you can retrieve that information and then pipe it to something else. What we do is we take that and then pipe it to Kafka. Kafka is another good platform for streaming data, and it has its own properties to allow data to be stored, replicated, and contained. And then you could either use Kafka itself, or you could get a connector, another connector, which we call this as a sync connector. There are a couple of sync connectors for ClickHouse. We have one of our own, which is more customizable for our own needs. And then we would pipe that to ClickHouse. And this will be the high-level architecture of connector. This is something we also worked on, both open source command line and also in the cloud. We integrated this technique to ActivePath, which I worked on about 6 months to get the proper data connected and dumped it in the Kafka. So Debezium has a one good option. It can take a snapshot of the origin source table. So when you connect it to, say, MySQL table, you have orders table, you connect and it takes a snapshot and it knows where it is. Once you start retrieving that data, it will actually continue taking that. Once that came in, it will start to see this change data capture. It knows where the changes are on that table. It will push towards Kafka. Kafka is a good staging area where you can actually strip down the data, take the one that you want, and then get it piped into the sync connector to piping code. So it could be anything, it could be Go. You could basically modify, customize as you need, and push it to ClickHouse. This system actually runs very nice if you actually customize it properly. Moreover, we turn this technique into a fabric. So the idea is the historical data sets comes in, and then you make a connection from the databases that you actually have on the other side for the OLTP or other storage, and use a system data fabric, which is a reverse proxy, to connect from, make a connection and archive it, and then feed it with the technique like this. It could be anything, and then go for the analytics, and then you construct that data. Basically, you can attach time series data store or the monitoring and visualization, and then you actually have it. So this is something we've been working on. This will be open source, hopefully by the end of Q2. And again, another open source tool. One will be the sync connector. The other one will be the proxy server. So how do I get started with ClickHouse? On your local, on your PC, you don't need the cloud, you don't need credits. Just install the ClickHouse, and then you can do a ClickHouse Connect, and then basically load some data and start playing around. I like Brew on my Mac. You can do Brew install ClickHouse. It'll install, you get a ClickHouse server, and okay, I think we are running out of time. Before I conclude this talk, I want to thank FOSSASIA organizers and this event. Thank you for coming in. How to contribute a community like this? I've written a blog post. You could actually get a link from here. There are a bunch of things you could do. In the Kubernetes communities, they say, Chuck would carry water. You don't have to do that maybe, but you can actually have sharing and spreading the word with others. Please take a look at this. This is my first book. Some of the concepts of how
what we've gone through today so far with MySQL is covered over here. JSON functions, replication, high frequency monitoring, and some of the application development access is covered in this book. There are about 200 recipes in it. This is my upcoming book, so we have good coverage for database design and modeling, also coverage for the scalability options, which you can actually, how you can get there. And thank you.
Thank you so much. Before the Q&A, is Pradeep in the room? So you are the wrong end of the room. This is the talking end. Please come down and send your machine up. We are before lunch, so your session actually starts now. While you're sitting up, we'll do a little bit of Q&A. Do we have any questions? Okay. Aha.
What is the most desirable feature you wait in ClickHouse eagerly instead of connected to our database?
Most desired feature I would want in ClickHouse. So I think one of the next talk is about the ClickHouse Keeper. So originally he's going to cover. We can set that up here. Originally, ClickHouse uses Zookeeper for cluster management. So it didn't have a built-in clustering management system. So so that was one desire that I think being taken care of the feature. There are like the tooling, because it's open source, the tooling around that we've been working on are the things that actually most desired was the backup and recovery, for example. So we built a backup suite around ClickHouse. The other one was online schema changes. So there's no such thing as online schema change in the analytics world, but it is required. So the source changes, okay, and then the destination, when you build a system like that and then you stream data, the destination is not changed. And how do you do that online without impacting? Because the idea is getting real time or near real time. If I'm having a downtime, that's not real time. So those are the things that my desired actions, and so we're building tooling. My team is actually building tools around because it's open source and we can add things. But out of the box, ClickHouse does what it needs to do. Of course, there are things that can be improved, but what's going on in the ClickHouse world in general is the machine learning and AI integration and things like that. Okay, thank you. Any other questions?
No, we're already over time. Unfortunately, because Pradeep is now between us and lunch, there isn't a 5-minute break between the two of you. So Pradeep, your clock is already running. You in fact now have 12 minutes to talk to us about coordination of Azure systems. Please go ahead.
Hello, thank you for coming to this talk. And I work at the ClickHouse Cloud. And in the previous session, you already talked about the ClickHouse and how ClickHouse is very fast and how it does things very different than traditional database. In this talk, I'm talking about a particular component of ClickHouse called ClickHouse Keeper. You can think of it as a coordination system. In the next 12 minutes, I'll talk about introduction about ClickHouse Keeper, why we build the Keeper, and how we run it in the cloud.
Not 20, you have 12 minutes. 12 minutes.
And quickly, then we look at community. So, as you know, any distributed system needs some kind of coordination, and Keeper is basically the coordinating system is the heart cluster. So Keeper basically in ClickHouse cluster, Keeper serves that purpose. So what does coordination mean? In a distributed system, you need some way that the state of the cluster is replicated across the cluster. Let's say in this example, if there are first 5 servers and a variable whose value is 100, you need to make sure that you query any of the
server of the cluster, the response is always different. And when we are updating the cluster, like any operation on the cluster, like deposit, withdraw, you need to make sure that the result from any of the cluster is always the same. So this is basically what coordination or consensus means. There are a lot of consensus protocol. 2000 access is well known, used by MySQL and etc. Then there is that which is used by Zookeeper, and most of the modern database uses a relatively easier and simpler consensus protocol for that. You might have heard it used by etcd, ClickHouse, and ClickHouse Keeper uses the same protocol. So you may ask why do we need a consensus protocol in ClickHouse? As I told you earlier, that ClickHouse is a distributed database because of its distributed nature, and there is no particular reader node. Every node is reader, and the client can connect to any of the nodes of the cluster and do a write operation. By write operation, I mean insert, update, delete. So because these are write operations, we need to somehow replicate it across the cluster, and that's where ClickHouse Keeper comes into the picture. Apart from that, there are a lot of internals of ClickHouse, like when a write operation happens, it's a block number, and this block number you can think as a distributed count, which gets allocated by ClickHouse Keeper, and it is the background operation called merges. In other databases, they call it compaction. Something similar requires Keeper. Then there is a distributed DDL queries, which is like on cluster queries. You run a SQL query and it runs on every node of the cluster and gives you an aggregated result that also uses ClickHouse Keeper. So you may ask why, when there is already so many coordination systems like Zookeeper, etcd, why we build one more system. Actually, when ClickHouse open source, it started with Zookeeper, and everybody used to run Zookeeper. Over time, what happened is like people started extending the boundaries of the capabilities. We were running at bigger and bigger scale. Sooner Zookeeper is actually able to keep up. And because the connection system is the heart of the cluster, it's very important. It needs to scale as the cluster is scaling. So we had to write our own ClickHouse Keeper implementation. From Zookeeper, like it's a backend coordination system, it's a very simple protocol, but there is few issues in the Zookeeper. That one is very important. Development of Zookeeper is not much happening, it's mainly bug fixes. Another thing is like there are issues which most customer users used to face is like there is an overflow. There's a design decision in Zookeeper where each node can only have 1 MB of the maximum set of data, which doesn't go as per the design of ClickHouse. Then, because it's written in Java, it's JVM coming into picture, the user needs to know how to do the tuning of JVM. And there are few other things like it doesn't compress the logs, and if there are too many writes, the logs can go pretty big, the snapshot can go pretty big. We wanted to compress the logs, and there's some checksums which we wanted to add. That's why we started writing our own implementation of ClickHouse Keeper in C++, which uses graph instead of that protocol, and it's fully compliant with Zookeeper. That means if you are using Zookeeper for like Kafka or Mesos or any other system, you can actually replace your Zookeeper with ClickHouse Keeper. And because it's written in C++, it is really very fast, and we use it in our ClickHouse Cloud, and it provides much lesser memory consumption. And there are other features also, and we test it using JetString, which you might know it's a distributed system testing tool which injects faults like network partitions, packet details, and file system corrections. So by default, people provides same guarantees as Zookeeper provides linear with the writes, which means that if you do a write, any bits after the write will always read that value. But and like non-realizable bits, same as Zookeeper, but one of the major requirements was we need to have our customers to be able to migrate
we never break the backward compatibility. But there's a tool which we provide for ClickHouse Keeper which converts the data, and we have a built-in client also, so anybody can basically connect to ClickHouse Keeper with the client. And one of the things is that you can run ClickHouse Keeper in embedded mode, so there is a separate process. Testing ClickHouse, you can run it in embedded mode, so you don't need to run a separate process. It runs as part of the ClickHouse server. Next, let's look at how we run as a ClickHouse cloud. So, at a very high level, just like any other coordination system, ClickHouse Keeper has a leader, few followers. Because we run 3-node cluster, we have 2 followers, and there's a graph consensus, and the Keeper client is the ClickHouse server connects to any other node. All write request in Keeper cluster goes to the leader, but the read request can go to any of the node. So let's say if in this example the request from the client is going to a follower, then the request is basically forwarded to the leader. So in this example, you can see we are creating a Z node in ClickHouse Keeper, which is going forward. The request is next forwarded to the leader. Basically, leader writes the append log, sends the append log request. The followers, those followers basically commit to the append logs, and finally, once the data is committed, once the ClickHouse Keeper cluster is sure that the data is written in the disk and it's not lost, it returns back to the client with an OK. So at a very high level, this is the architecture. In ClickHouse Cloud, we provide a dedicated Keeper cluster, which is a 3-node cluster. The reason why we can't increase the cluster size is because in our coordination system, if you increase the cluster count, basically you get higher throughput or read request, but now your writes needs to be propagated across the cluster on all the nodes. So your writes will become slow, so we don't do horizontal scaling, but we actually provide vertical scaling vertically. So we increase the resource of CPU and memory as the request from the server comes more. Another thing we ensure is like the Keeper cluster restart can actually impact the server. So we ensure that the restart is done gracefully so that any write request is not impacted. And we also recently added a new feature which basically ensures that Keeper provides higher priority to the server node, gives higher priority to the Keeper, which will take the previous node so that the latency between the server and Keeper is less. A very simple architecture is like this 3-node cluster, and we scale up the servers horizontally and vertically. So let's quickly look at what are the challenges which we are facing. One is the very in any coordination system, because we need to provide linearizability guarantees. All the transaction which is happening from all the servers need to end up in a single queue, which is a single threaded and runs only on single CPU. This is one of the major reasons, even if you scale up the cluster vertically, you might not get better performance. So one of the things which is coming in ClickHouse Keeper is basically multi-graph support. And what does it exactly mean is each server will be given a different draft instance within the Keeper cluster. So and each of these drafts can run independently, so they can utilize the CPUs much better. With that, I would like to say thank you for coming to this session and thank you for giving me this opportunity to speak. I would like to take any questions.
That's an impressive adaptation to a compressed schedule. Thank you. We actually have time for one question as well. Go once, go twice. Oh.
Have you tried running benchmarks against Keeper and compare like vanilla implementation with current single ClickHouse Keeper and this upcoming multi-draft? What's the kind of performance gains to expect on the typical setup?
Thank you for the question. Basically, this multi-draft support is still in implementation phase. We haven't added it's not really the full request or anything to end it. But we definitely have done benchmark for Keeper or Keeper, and definitely the Keeper performed much.
Is it published somewhere?
Yes, there is a blog. Sorry, I forgot to link the blog here, but there is a ClickHouse blog.
Thank you again. We are now breaking to lunch. We're back here at 1:30. Thank you.